So once again, good afternoon to all the participants. So in this session, I am going to discuss about various clustering approaches used in the machine learning models. So this is the outline of the talk. So I'm going to discuss about what is clustering, what are the different types of clustering available. Then I'm going to discuss about these 5 or 6 types of clustering approaches. What is the method behind these approaches to cluster a given data set. Right. So basically, I'm going to talk about k-means clustering, hierarchical clustering. So under hierarchical clustering, I will discuss about the two techniques. Then the DB-scan clustering. This is a density-based clustering. Then some graph-based clustering I will tell. And at the end, fuzzy clustering or the fuzzy C-means I will discuss with an example. So, as the FDP is for artificial intelligence for engineers, right? So, you may have gone through different sessions or various sessions on the machine learning models also, right? So, generally, the learning happened in two cases, right? In the supervised learning and the unsupervised learning. So, in the supervised learning, we are having like level data. So, the presence of the outcome variable is available to guide the learning process. So for every data set, for every input, right, some attributes will be there and the level attached to this input will be given. So there must be a training data set in which the solution is already known and we have to train the model. Then we have to test for a portion of the data or to check the performance of the model. So coming to the unsupervised learning, generally there is no label data exist in this case. So the outcomes are unknown. That means for a given set of attributes of the input, there is no output, right? So we have to cluster the data. We have to group the data to reveal some meaningful information present inside the data. So for that, we have to do the partition of the data sets, or we have to do the hierarchy among the data sets to reveal the inside information present in the data set among the various data points. So this clustering approaches is coming under this unsupervised learning where the training data is unlabeled. So we have to apply some procedures or the technique to divide the data points into a set of clusters. So generally, right, suppose this is a sample, we are having different objects are there, right? So what we have to do, depending upon some similarity or the dissimilarity measure, we have to group this data into various clusters, right? So the similarity or the dissimilarity measure that we have to define, maybe Euclidean distance we can use or the cosine similarity we can use. Then applying that similarity, we see which data points are belonging to one group, right? So then the original sample data, it can be divided into number of clusters or the number of groups. So in case of clustering, generally we are using the Euclidean distance as a similarity measure to group the data points. Suppose you will see in this left side figure, right? So these are the points which are having your minimum distance among themselves. So this will form a cluster, right? Similarly, this will form this side, it will form a cluster. Similarly, the remaining part, this will form a cluster, right? So how to define this Euclidean distance and how to determine how many clusters are required to partition the data set, it depends upon the methodology you are using to cluster your data. So coming to the different types of clustering techniques, generally the clustering techniques, these are divided into partitioning method, hierarchical method, density based method, graph. If somebody has unmuted, please mute the participant. Okay. Graph-based method, and the last one is your model-based clustering. Right. So under every technique, there are other subdivision of these methods are there also. So under the partitioning methods, right, there are k-means algorithm is there, k-medoid algorithm is there, k-modes algorithm is there, a fuzzy C-means clustering algorithm is there. So out of this, I will discuss about this k-means algorithm and the fuzzy C-means algorithm. Coming to the hierarchical method, so we are going to talk about this divisive algorithm and the agglomerative method, how they are used to cluster a given data set. right? So there are other different types of approaches exist under each category. So you can explore those techniques, right? So coming to the density-based methods, there are subdivisions here. Sting is there, DB-scan, click, DenQ, optics, wave cluster. So I'm going to discuss about this density-based spatial clustering of applications with noise. So this technique I will discuss. Then graph-based methods, if you are able to represent your data set through a graph, so you can go for the within graph clustering or right and between graph clustering also you can do. It depends upon your problem, which problem you are having, and if you are able to represent your problem through a graph, that means a set of vertices and a set of edges. So here under graph-based methods, we are having this minimum spanning tree clustering, right? OPSM is there. The similarity neighborhood measurement is there. So out of this, I will discuss about this MST clustering and the similarity clustering, how to do with the graph is given. Then the model-based clustering, there are expectation maximization algorithm is there, autoclass is there, cobweb is there, ANN clustering is there. So I am not going to cover this part, the model-based clustering. Maybe, right, in the artificial intelligence part, maybe some sessions are there for the expected maximization algorithm or the ANN clustering under the machine learning. So basically, I'm going to discuss about this K-means, fuzzy C-means, and the divisive, agglomerative, on DB scan, minimum spanning tree clustering, similarity neighborhood measurement clustering, and the this thing. And up to last at the end, I will tell the fuzzy C-means algorithm. So how to do this clustering evaluation? Once we have divided our data into several groups, so you can manually inspect the clusters, right? It depends upon your problem domain. If you are having some benchmarking on the existing levels on the existing data, you can evaluate also. And the cluster quality measures, right? How to measure the cluster quality? For that, we are using the Euclidean distance, and we have to take care this thing, high similarity within a cluster and low similarity across the clusters. So these two things we have to follow whenever we are forming the clusters for a given data set. So generally the distance function, right? Suppose we are having one attribute in the data, right? So the distance we can calculate simply whether between 2 points x and y. So the attribute value for the data point x minus the attribute value for the data point y. If your data set has several numeric attributes, then the distance between 2 points x and y, you can use the Euclidean distance or the cosine similarity. Again, under the cosine similarity, you are having L1, L2, L3. So mathematical functions are there. So you can use those similarity to find out the distance between the 2 points. So here only I am going to discuss about this Euclidean distance, how to use this Euclidean distance to form clusters. If your data set, right, you are having multiple attributes, right, whether all the attributes are equally important, right, for that also you have to do some analysis. So you can go for assigning weights to the attributes, and the attributes which are having the higher weights, those attributes also you can form clusters among themselves, right. So weightage you have to find out for the attributes. So coming to the first one, that is the partitioning method. Your K-means algorithm is coming under your partitioning method, where you are dividing the data set, or you are partitioning the data set into number of clusters. So your K is the predefined or the user-defined value, which represents the number of clusters. So K-means clustering algorithm. This is proposed by J. Hattigan and M.A. Yuan in 1979. This is a very old algorithm, right? So if we are having a data set of n distinct objects, so the K-means clustering algorithm, it partitions the n distinct objects into k number of clusters. As I told, k is the user-defined value, predefined value. So n distinct objects you are partitioning among the k number of clusters. So as that, so as I told in the previous slide also, you have to take care of this one. Intra-cluster similarity should be high and inter-cluster similarity should be low, right? So as the k is the user specified value, user has to specify the value, k value. Again, it depends upon the problem domain, right? The number of clusters. And consider the objects are defined with numeric attribute only. So whatever your data sets we are having, all the attributes should contain numeric attributes. Then only you can go for this k-means clustering algorithm. And you can use any distance metric for the similarity measure, right, to demarcate the boundaries of the clusters. So Euclidean distance we'll use here for defining the clusters, right? So which data points are coming under which a cluster. So how this algorithm works? This is very simple algorithm. First, it selects the k number of objects randomly from the set of n objects. So whatever the user is specifying the k value, randomly k number of objects you have to select from the n objects, right? So these k objects are treated as the centroids of the center of gravity of k clusters. So initially we are having k number of clusters, and whatever k number of random points we are selecting from the n objects, those k points will form the centroid or the center of gravity for those clusters. Now, for the remaining objects, what we have to do, right? We have to assign the remaining objects to one of the closest centroid. So, how to find out the closest, which point or which object is closest to which centroid or which cluster? For that, we have to find out the distance between the remaining object, each remaining object, and the cluster centroid, right? So, thus it forms a collection of objects assigned to each centroid, and this is called a cluster, right? So once the new objects you are assigning to a cluster, the centroid of the cluster will change, right? So next, the centroid of each cluster is updated. So you have to calculate the mean values of attributes of each object present in each cluster, right? So again, same procedure you have to follow, right, until the termination criteria reaches here, right? So what are the termination criteria here? Are the you are doing for a certain number of iterations, or your centroid remains unchanged, there is no change in the centroid of the clusters, or you are not able to assign new objects to the clusters. So under this scenario, the process, right, you can stop your process here. Otherwise, you have to the assignment and update procedure you have to carry out until this criteria, until one of the criteria is satisfied. Again, you have to fix your termination criteria, right? What you want. Suppose we want how many points should be there in each cluster, or you don't have time. I have to iterate for only 5 iterations, right? Whatever result I am getting, that with that result I have to satisfy. So here, if you write the algorithm of this k-means clustering, so we are having the input on D is a data set containing n number of objects, and k is the user specified value, that is the number of clusters. So output we have the k number of clusters, and these n objects are partitioned into this k number of clusters. So which object is going to which cluster? That is our output. So as I told in the previous slide, you have to randomly choose k objects from the dataset D as the initial cluster centroid, right? Then for each of the remaining objects in the dataset D, what you have to do, you have to compute the distance. So here we'll use the Euclidean distance between the current object and the k cluster centroids, right? Then assign the current object to that cluster to which it is closest. So suppose we are having a data point x1, and we are having 3 clusters, right? C1, C2, C3. So we'll find out the Euclidean distance between this data point x1 with the cluster C1, I mean the centroid of the cluster C1. Similarly, distance between x1 and C2, distance between the x1 and C3. So whichever distance is minimum, right? Suppose this is the 10, this is 15, this is 20. So this 10 is minimum, right? So we'll assign this x1 to the cluster C1. So assign the current object to that cluster to which it is closest. Then what we have to do, we have to update the cluster centers or the cluster centroid, right? So compute the cluster centers for each cluster. So this becomes the new cluster centroid. So we have to repeat this step 2, 3 until the convergence criteria or the termination criteria is satisfied. Then you have to stop here. So this is the basic algorithm of this k-means algorithm. So let us do one example for this k-means clustering algorithm, how it works. Suppose we are having, right, this is the data set D, having 2 attributes are there, A1 and A2, right? So there are, I think, 15 or 16 data points are there in the data D. So assume the k value is 3. User has given the k value as 3. So randomly we have to select three data points out of this, I think 3, 6, 9, 12, 16. 16 points are there. So the size n equals to 16, k equals to 3. So out of this 16, randomly three objects randomly I have to select. I think that is this point is selected randomly 3.8, another point is 6.8, 2, another point is 7.8. This point. These 3 points are selected randomly. So this is the plotting of the data, right? This x-axis represents the attribute A1, y-axis represents the attribute A2. Okay, so these are the points present in the scattering. This is the scattering plot. So here this 3.8. This is the first point, random point. This is the 6.2. This is the, I think, 7.8. These are the three clusters initially. So the cluster centroid initially are this one, 3.8 for the cluster C1, 3.8, 9.9. For the cluster 2, 6.2, 18.5, plus cluster 3, 7.8, 12.2. These are the cluster centroids of the three clusters. And for the remaining 13 points, now what we have to do? We have to find out the Euclidean distance between each point and with each cluster, right? So here, whatever I told you, these 3 points are selected randomly. These are their centroids initially. Okay. So now you have to find out the Euclidean distance between the remaining objects or the remaining points in the data set D and each of the cluster centroids C1, C2, C3. Assume that is your D1, D2, D3. It denotes the distance from an object to cluster C1, C2, and C3 respectively. Right? Now let us see how this is the, suppose you see this one. So this is the data point. This is the data point your D. Okay, original data. This is the D1, D2, D3. So D1 with respect to cluster C1, D2 with respect to cluster C2, D3 with respect to cluster C3. So this is the point 6.8 and 12.6. This is the first point in the data set D, right? So you have to find out the Euclidean distance with this point with the cluster C1, right? So the cluster C1, the centroid is given 3.8, 9.9. So you find out the Euclidean distance. So you will get 4, right? Similarly, for the cluster 2, you will get 1.1. For the cluster 3, you will get 5.9. And the last column, it represents to which cluster we can assign this data point. As this data point, right, this is with respect to cluster C2, right, the distance is minimum. We are assigning this data point to the cluster 2, right. Similarly, for the remaining objects, we have to do the same procedure we have to apply. Now we can see in the cluster 2, right? Previously in the cluster 1 point was there, cluster 2, 1 point was there, cluster 3, 1 point was there, right? Now you see in the cluster 2, we are getting 1, 2, 3. 3 points we are getting. Cluster 1, we are getting 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And the remaining we are getting in the cluster 3. 2, 3. Okay. So now this is the previous, if you see, this is the plotting and this is the cluster centroid. Now the cluster formation is changing, right? New remaining objects you are assigning to each of the cluster by using the Euclidean distance. So this is the cluster C1, this is the cluster C2, this is the cluster C3. Now what you have to do, you have to update the centroid of these clusters, right? So how to update the centroid of these clusters? Now you see this cluster C1, how many points are there? 3, 3, 6, 3, 9 points are there. This is the 9 point, these are the 4 points, these are the 3 points, right? So what you have to do for attribute A1, right? So in order to find out the centroid of the cluster C1, you have to find out the average of the attribute A1 and you have to find out the average of the attribute A2. So those points belongs to the cluster C1. Similarly, the centroid of C2 you can calculate by using the average values of these 3 points for each attribute. Similarly, the centroid of C3 we can calculate by taking the average of attribute A1 and A2 for these 3 points, right? So if you do the calculation, same calculation, you will get the C1 4.6, centroid is 4.6, 7.1, C2 8.2, 10.7, C3 6.6, 18.6, right? Now these are the centroid, right? Previously we were having the centroid is represented by the red dot. Now your centroid is changing. Okay, so this is the calculation of the new centroid, and this is the plotting, right, or the objects belonging to which cluster. Yeah. Next, you have to repeat the same procedure again, right? What you have to do, you have to find out again the distance, right, from the remaining data points to these each of the cluster. And if you see whether you are able to assign any new objects to these clusters, right? So we next reassign the 16 objects to these 3 clusters by determining which centroid is closest to each one. Okay, so this may give us the revised set of clusters, whatever we are getting here. Now, if you see previously, right, this point P, right, it was coming under this cluster C2, this point. We are talking about this point. Now, after doing one more iteration, this point is coming to cluster C1, right? So again, you have to find out the cluster center by applying the same procedure. So here again, you will get 5.0, 7.1, 8.1, 12.0, 6.6, 18.6, right? If you consider, right, suppose this is the termination criteria for after 3 iterations, or there is no change in the cluster centroid, you have to verify that one, right? So here you can, for this particular example, you can see that our centroid C3 is unchanged, right? It is not changing in the next iteration. Where your C2 and C1 is changing, but there is no change in the C3 centroid, right? So with respect to the newly obtained cluster centers, the 16 points are reassigned again. So these are the same clusters as before. So hence their centroids also remain unchanged. Okay. So if you consider this as the termination criteria, so your k-means algorithm stops here, right? And this is the final clustering, right? So out of these 16 points, I think 4 points are coming here, 4 points are coming here, C2, and the remaining points are coming under C1. Sorry, this is the C3, C2, and C1. Right. So the termination condition you can consider as the number of iterations, or the, right, there is no change in the cluster centroid, right? Or what you can, a predefined cluster, right? Predefined threshold value if you are keeping. Suppose 10 points are coming under cluster C1, 5 points are coming under cluster C2, 1 point is coming under cluster C3. So in that scenario also you can terminate, right? So this is a very simple algorithm. So this is very smooth in terms of your interpretation and the resolution, because the algorithm is very simple, right? So for a large number of variables present in the data set, k-means operates quicker than your hierarchical clustering, right? So while redetermining the cluster center, an instance can modify the cluster, that we have seen in that particular example, the point P, right? In iteration, point P is coming under C2, and the next iteration is right, is moving towards the cluster C1. So k-means reforms the compact clusters, right? So it can work on the all-level numerical data only. If the numerical data is there, then you can go for the k-means clustering, right? Moreover, it is very fast, robust, and very easy to understand, and it yields the best outcomes when your data sets are thoroughly separated from each other, right? If the data sets are not thoroughly separated from each other, right? So what will happen whenever you will find out the Euclidean distance between the data points and the clusters, the value will remain same, right? So in that scenario, we can decide whether it is coming to cluster C1, cluster C2, or cluster C3. So coming to the limitations of the k-means clustering, as we know, k is the user-specified value, right? So in the clustering or the partitioning of the data into number of clusters, it depends upon the value of k, right? So the output is highly influenced by the original input. Original input means your number of clusters, right? So if you know the, right, if you are initializing the value of k, the proper initialization you are doing, then only you will get a good partitioning of the objects among the k clusters. Otherwise, that will be meaningless, right? So in order to write that user specified value k is required in the partitioning method for the k means clustering, right? So we'll use this hierarchical clustering where there is no requirement to find out, right, or to initialize how many clusters we want, right? So that k value is not required in this hierarchical clustering. So under hierarchical clustering, so there are two methods. One is your agglomerative clustering. Second one is your divisive clustering. Okay. So agglomerative clustering, what we have to do, it will start with a single instance clusters. Okay. That means every data point is considered as a cluster here. initially single turn clusters will be there. So I will explain through an example in the next slides. So at each step, you have to join the two closest data points. Right? That means we are joining two points to form the clusters. So here, how to take the decision here? Your distance between the clusters, so the distance between the data points, you have to consider to determine which points you are going to cluster. Right. So basically, this agglomerative clustering, this is a bottom-up approach, and this the reverse is the divisive clustering. So divisive clustering, it start with one universal cluster. All the data points initially remain then in one cluster. Then what we have to do at each step, we are going to divide the cluster into two clusters. Right? Every iteration, we are dividing each cluster into number of clusters. Again, the distance between the data points is considered as the criteria to partitions. Right? So it's proceed recursively on each subset, and it can be very fast also than the partitioning algorithm, right? So whenever we'll apply the agglomerative clustering or the divisive clustering, we'll get a dendrogram, right? So what is this dendrogram and how to find out the clusters from the number of clusters from the dendrogram? We'll discuss through a proper example so that you can understand. Now, coming to the agglomerative clustering, as I told, this is a bottom-up approach under your hierarchical clustering, right? So this structure is more informative than the unstructured set of clusters written by the flat clustering. I mean the K-means clustering. Okay. So this agglomerative clustering, it doesn't require us to pre-specify the number of clusters. As we are doing in the K-means clustering, the value of K we are assigning, right? So in the agglomerative clustering, this value of K, this assignment of the pre-specification of the number of clusters is not required, right? So as I told, each data point is considered as a single turn cluster here, right? So initially each data point is considered as a cluster. Then successively we are going to add the data points to form clusters, right? Until all the clusters have been merged into a single cluster that contains all the data. So how to cluster, right? How to form groups among the data points? For that we have to use the Euclidean distance, right? So this algorithm is also very simple for this agglomerative hierarchical clustering. We are having a given data set D1 to Dn of the size n. Okay, so what we have to do, we have to compute the distance matrix. So the distance matrix is the Euclidean distance between the 2 points. Okay, so for I equals to 1 to n, you have to find out the distance matrix. So as the distance matrix is symmetric about the primary diagonal, right? Suppose we are having 4 points. So this is the, right, your 4 cross 4 matrix you will get. Okay. So these are your diagonal elements are 0. Okay. So as this is a symmetric matrix, so our target is to find out this lower part of the diagonal matrix. So these things we are going to determine. Okay. So as the distance matrix is symmetric about the primary diagonal, this one. So our target is to find out the lower part of the primary diagonal. So how to find out? So distance between 2 to 1. So the Euclidean distance between the data point 2 and the data point 1. Similarly, the distance between 3, 1, 2, you have to find out the Euclidean distance between 3 and 1. You have to find out the Euclidean distance between 3, 2. Similarly, between 4, 1, 4, 2, 4, 3. Right? So for that, this is the for j equals to 1 to I, because our target is to find out the lower part of the primary diagonal. So the distance matrix Ij entry will be the Euclidean distance between 2 points Di and Dj. So initially what we are assuming, each data point is a single turn cluster here. Okay. Then what we have to do, we have to merge the two data points having minimum distance into a cluster. So merge the two clusters. This is not cluster, this is merge two data points having minimum distance. Then we have to update the distance matrix until only a single cluster remains. If you are able to cluster all the data points into a single group, at that point we have to stop here. So let us do one example how this works. Suppose the structure is like that. We have, suppose 6 data points are there, A, B, C, D, E, F. Okay, in the first level, suppose D, E, they are having minimum distance. So D, E, we are forming into one cluster. Then B, C, they are having the minimum distance. So B, C, we are combining. Okay, next D with respect to D and the F, next iteration. they are having minimum distance. So we are combining D, E, and F. Next, D, E, F, and B, C, they are having the minimum distance. So we are combining into B, C, D, E, F. And finally, B, C, D, E, F, and A, we are combining into this one. So at this step, we are getting the single cluster, which contains all the data points, right? So from this, we'll get a dendrogram. And from this dendrogram, we have to decide how many clusters exist for that particular data set. Right? So let us do this small example. Suppose we are having 5 data points, 1, 2, 3, so value capital N, right? Number of data points exist in the data set equals to 5. So this is the distance matrix. Assume we have determined the distance matrix. I mean, from the attributes present in the data set, we have applied the Euclidean distance and we have calculated the lower part of the primary diagonal. If you see the primary, right, the diagonal elements are 0, or distance between 1, 1, 2, 2, 3, 3, 4, 4, and 5, 5 are 0. Right? So the lower part of the diagonal we have calculated by using the Euclidean distance. So initially we are assuming that there are five singleton clusters, right? Cluster 1, cluster 2, cluster 3, cluster 4, and the cluster 5. Now we have to combine, right? At each step we have to combine 2 data points into a cluster. So how to do this one? If you see this distance matrix, right? So here the distance between 5 and 3 is minimum. You see all the values present in the lower part of the primary diagonal, 2 is minimum, right? So as the distance between 5 and 3 is minimum, so we are going to combine this 5 and 3 into a single cluster. Now we are having 5 clusters: cluster 1, cluster 2, cluster 3, cluster 4, cluster 5. Now the distance between data point 3 and the data point 5 is minimum. So we are going to combine 3 and 5, right? So now what are the clusters now? 3, 5 will be combined. So this is one cluster. Then the remaining singleton clusters are 1, 2, 4. Again, you have to update the distance matrix, right? So again, under your agglomerative hierarchical clustering, there is complete linkage clustering is there, single linkage clustering is there. So in the complete, so we are discussing this complete linkage clustering where the distance will be updated by using the maximum value of the Euclidean distance. And in the single linkage clustering, just you have to do the minimum distance, right? For the updation in the distance matrix. Now we'll see what will be the number of clusters and how the distance matrix looks like, right? So as the distance between 5 and 3 is minimum, so we are going to combine now. See, 3, 5 is one cluster, then cluster 1, 2, 3, 4. Again, we have to find out the distance matrix, right? Again, 3, 5, 1, 2, 4. As the primary diagonals, right, all are 0 here, right? So our target is to find out the lower part of the primary diagonal. Now, how to find out this one from cluster 1 to cluster 3, 5? Now you see here, from the here we have to find out. So you see, from the 1 to 3, the distance is 3. From 1 to 5, the distance is 11, right? So what is the distance between the 1, 2, 3, 5? So in the complete linkage clustering, you have to consider the maximum value. And in the single linkage clustering, you have to take the minimum value. So out of this 3 and 11, the value is 11. That's why the distance between 1 and 3, 5 is 11. Similarly, 1 to 1, this is 0. Now let us see 2 to 3, 5. So cluster 2 to 3, 5. Now you see cluster 2 to this is coming 7. Cluster 2 to 5, this is 10. So which is maximum? 10 is maximum. That's why 2 to 3, 5 is maximum. And 2 to 1, already this is given 9. 2 to 1, this is given 9. So this is 9. So again 2 2 is 0. Okay. Next, let us see from 4 to 3, 5. So 4 to 3, 5. Now see 4 to 3, this is 9, right? And 4 to 5, right? This is the 4 to 5, this is the 8. So which is maximum? 9 is maximum. That's why 4 to 3, 5 is maximum. And 4 to 1 already it is given here. And 4 to 2 is also given in the previous. Only for the new cluster, whatever you are performing, that value will be updated. So this is the distance matrix in the next iteration, right? Again, you have to follow the same step. Now you see the distance between the cluster 4 and the cluster 2. These are the two singleton clusters, right? So this is minimum, 5 is minimum. So what you have to do? You have to combine 4 and 2. Now you are getting another cluster 2, 4, right? So now 3, 5 is there. you are combining 2, 4 and 1. So these are the 3 clusters you are getting. Similarly, you have to update the distance matrix here also. So this is 3, 5, 2, 4, 1, 3, 5, 2, 4, 1. All the primary diagonals are 0. And by using this complete linkage criteria, right, by using the maximum value on the distance matrix will look like this: 10, 11, 9, 0. Again, you will see here 1 and 2 for the distance is minimum, right? So what you have to do? You have to cluster 1 to 4. 1 with 2, 4. That means you will get a single cluster, that is the 1 to 4. Now the cluster will be 1, 2, 4, 3, 5. Again, you have to find out the distance between 1, 2, 4 and the 3, 5. See, this is the distance, right? So here what will happen? The distance between 1, 2, 4, 3, 5, this is minimum, right? So here what you have to do? You have to cluster 1, 2, 3, 4, 5. So at this point, you are getting a cluster which contains all the data points. So you have to stop here, right? So initially what we have done, we have clustered, initially we are having 1, 2, 3, 4, 5. We have clustered 3, 5, right? This is 1, 2, 4. Then 2, 4 we have clustered 1, 2, 4, 3, 5. Then we have clustered 1, 2, 4. This is 3, 5. And finally we got 1, 2, 4, 3, 5. This is the division, right? So how many clusters are there in this, right? So for this, we have to find out. So this is the dendrogram. Dendrogram, that is a tree structure you are representing. That means 3, 5 you have combined first. Then 2, 4 you have combined. Then 1, 2, 4 you have combined, right? Then finally 1, 2, 4 with 3, 5 you have combined. So from this dendrogram, how to find out the number of clusters? Simply if you do the reverse, that is the single linkage dendrogram. That means for updating the distance matrix, you have to consider the minimum value here. Okay. So if you apply the single linkage, you will get the dendrogram. So initially your, all right, 3, 5. Okay. Then 1, 3, 5 will be combined. Then 2, 4. Then 1, 3, 5, 2, 4. So different points you are combining into different clusters here. So from this dendrogram, what you have to do, how many clusters are there, you have to decide, right? So there is no objective way to say how many clusters are there, right? So what you have to do, you have to partition this dendrogram. You have to partition, right? You have to draw a line here. If you draw a line here, you will get for this diagram, this is one cluster, this is one cluster you are getting. So there are two clusters here, 1, 3, 5, 2, 4. Two clusters we are getting, where the data point 1, 3, 5 belongs to the cluster 1, and the for data point 2, 4 it belongs to the cluster 2, right? So determining the clusters from the dendrogram is also a difficult task, right? If you draw the line here, now if you see, so it will combine. This is considered as a one cluster. So all the data points are coming under one cluster. So it depends upon how you are going to divide or how you are going to partition the dendrogram, right? So the number of clusters will be determined by using this partitioning in the tree-like structure, that is the dendrogram in the agglomerative clustering. So the advantage of this agglomerative hierarchical clustering is that we don't require any prior information about the number of clusters required. This is also very easy to implement, and this may gives the best result in some cases if you are able to partition the dendrogram properly, right? And the disadvantage is that if you see the algorithm, right, if it is partitioning, every time it is partitioning the points, the time complexity is at least it will take your n square of n square log n, right? So where n is the number of data points. So as I told, sometimes it is also very difficult to identify the correct number of clusters by the dendrogram, because if you are doing different partition in the dendrogram, you are getting different number of clusters. So which partition you have to consider? That is the most disadvantages in the agglomerative clustering, right? Next one is under this hierarchical clustering. Divisive hierarchical clustering is there. Just this is the opposite of your agglomerative. So in the agglomerative clustering, we have done the bottom-up clustering. Here you have to do the top-down clustering, right? So in the divisive hierarchical clustering, we have to take into account all of the data points as a single cluster, right? In every iteration, then we have to separate, or you have to divide the data points from the clusters which are not comparable. So at the end again, we are left with n clusters, and this is a top-down approach, right? Similarly, here also we can use the distance matrix to divide the data points into number of clusters. Right? Just this is the opposite as I told you. So initially, all the data points will be in a single cluster. Then every iteration you are dividing these points into two clusters. Now see A, B, C, D, E, F. Again by using the distance matrix. Suppose right, you are dividing into two parts, A and B, C, D, E, F. In the next step, B, C, D, E, F, you are dividing into two steps, B, C, D, E, F. Right, in the next D, E, F, it's divided into D, E, and F. Next step, B, C is divided into B and C. D, E is divided into D, E. Now, all the data points forms a singleton cluster. Right, so just the opposite of your agglomerative clustering. So how to do this one, right? If you are having a n number of data points, by using the Euclidean distance, how to find out the number of clusters. And assume there are here also it's a small example having 5 points A, B, C, D, E, and assume the distance is given here. Okay. So this is also a symmetric, right? So the symmetric matrix. So what we have to do, initially we are assuming that all the data points are in a single cluster. So initially A, B, C, D, E, it forms a single cluster. Now how to split this A, B, C, D, E into two clusters? Because this part we have to divide into two clusters. How to split? So this one you have to do in the step 1. Then after splitting this one, right, again you have to do the same procedure for each cluster, right? Whatever you have done in the step 1, again you have to follow for each cluster formed from this A, B, C, D, E. Now let us see how this works. Here see what you have to do, as we are having 5 points A, B, C, D, E, we are trying to divide it into two clusters, right? So which data points will form cluster 1 or which data points will go to the cluster C2. This is our target. This is the C1, this is the C2. So for this, we have to calculate the distance between a point to all the remaining points, right? So that is the A to other points distance. So from A, we are going calculating the distance from A to other points. So what you have to do, if you see the A, now this is the B is 2, 6 is 6, D is 10, E is 9. This is the Euclidean distance already we have calculated. So you take the average. Okay, mean of 2, 6, 10, 9, you will get 6.75. Similarly, from B to other points. So B means now you have to take A, 2, 5, 9, 8. So you take the mean of 2, 5, 9, 8, you will get 6. Similarly, for the C, you take the mean of 6, 5, 4, 5, you will get 5. Same method you apply for D, you will get 6.5. Same approach you apply for E, you will get 6.25. Right? So whichever is having the maximum distance, right, that will be partitioned. Right? So here you can see A to other points distance, I mean A to B, C, D, E is 6.75. So we are trying to divide A, B, C, D, E into two clusters, where A will present in the cluster C1, then B, C, D, E will form another cluster. Right? So this is they were doing in the step 1. A will form a cluster. Second, your B, C, D, E, this will form another cluster. Right? Now next what we have to do? Now B, C, D, E, right? B, C, D, E, we have to see what is the distance from B to remaining 3 points in the cluster, right? So for B, remaining 3 points are C, D, E, right? If you see from B to C, D, E, C, D, E, 5, 9, 8. You take the mean of 598, mean of 598, you will get 7.33. And B to first cluster. First cluster, what is there? A is there because we have divided the A, B, C, D into two clusters. So A is there in the first cluster. So B to A, this is the distance is given 2 here. Okay. So what we are getting? 7.33. B to other points in the second cluster is 7.33 distance, where B to first cluster A, the distance is 2. So 7.33 is greater than 2. So what we'll do? We'll move the point B into the cluster A. That means in this cluster A, B, C, D, is there any possibility that any point from this cluster C2, B, C, D, it will come to the cluster A, right? So you follow the same. You see the calculate the for C2 remaining 3 points within the same cluster, you will get 4.67. D to remaining 3 points, 5.33. E to remaining 3 points, 5.33. So this is less than, right? This is less than, this is less than. So only for this B, that means the point B is nearer to the point A. So what we'll do, we'll move the point B from the BCD cluster to the cluster A. Now we are having two same clusters, but the points are changing. Now you see A, B and C, D, E. Next, what we have to do, we'll check whether from the CDE, right, any point, is there any chance to move any point from the CDE to the cluster AB. So same procedure will follow, and what we'll do, until we get the singleton clusters, we have to follow the same procedure. Again, you see now this A, B, C, D, E. So CDE, for C to D you will get 4.5, D to CE you will get 3.5, E to CD you will get 4. Okay, so already this is C to AB. C to AB for point A and B. Mean of 6.5. This is the 5.5. This is 9.5. This is 8.5. So what is there? Now you see all value. This is less than, less than, less than. That means no point from CDE will move to the cluster AB. Right? So what we are getting here? We are getting only two clusters, AB and CD. Okay. So initially we are having A, B, C, D, E. Okay, we are converted into A, B, C, D, E. Now B is coming to this cluster. This is A, B, this is C, D, E. So the same step, in the second step, we have to follow the same procedure until we get the singleton clusters. Right? So what we have to do in the step 2, we have to choose a current cluster and we have to split as we have done in the step 1. So choose a current cluster. That means we are trying to split this AB. Again, we are trying to split this CDE. The way we have splitted A, B, C, D, E, same procedure we have to follow for AB and we have to follow for CDE. So which cluster we have to consider first? Whether we have to consider AB or we have to consider the CDE. So generally what happens? We have to split the cluster with the largest number of members first. So in this scenario, CD will be considered first for partition, right? Or you can consider the split the cluster with the largest diameter also maximum number of points. Okay, so CD will be considered. So the same procedure, step 1 you have to follow here. You have to split the chosen cluster as in the step 1. So this step you have to repeat until each cluster contains a points, or there are k clusters. So here also we can assume we want 4 clusters, right? So whenever you are getting 4 clusters having the data points divided, partitioned into these 4 clusters, at that point you can stop, or until you got the singleton clusters A, B, C, D, E, F, right? At that point you can stop here. So this is the procedure or the way by which the divisive hierarchical algorithm works, right? So here also from the divisive we can got the dendrogram, right? Again from the dendrogram we can do that partition, we can draw that line and we can determine the number of clusters, right? So that in getting exact number of clusters from the hierarchical clustering is sometimes it is difficult, right? So in order to avoid those things, your density based clustering approaches are there. So under the density based clustering approach, we are going to discuss about this DBSCAN algorithm. So this DBSCAN means your density based spatial clustering of applications with noise, right? So your outlier data point or the data points with noise, right? So these are we are going to eliminate here because they will not form any cluster here, right? So the main idea behind this DBSCAN is that a point belongs to a cluster if it is close to many points from that cluster. So how to define whether a point is close to many points from that cluster? So for that, we need two parameters in the DBSCAN algorithm. One is your EPS, right? So EPS is the distance that specifies the neighborhood. So when two points are said to be neighbors to each other, if the suppose there are 2 points X and Y, so can you say X and Y are neighbors to each other? So for that, we will have to know the EPS value between the 2 points, right? So that EPS value, it defines the distance for neighborhood. Suppose the EPS value equals to 2, we are specifying, or this is the user defined value, EPS equals to 2. So if the Euclidean distance between these 2 points X and Y is 2, we can say that X and Y are neighbors of each other, right? So 2 points are considered to be neighbors if the distance between them are less than or equals to EPS. So this should be less than equals to EPS. Okay. If it is greater than EPS, the distance between 2 points, then we cannot tell that those 2 points are neighbors to each other. because the neighboring points concept is required for this one, right? Because a point will belong to a cluster if it is close to many points from that cluster. So the closeness will be determined by the neighborhood function. And how to find out the neighborhood? That will be determined by the EPS value. Second one is mean points, mean PTS, right? So this is the minimum number of data points required to define a cluster. So how many points are required? Minimum number of points are required for forming a cluster. That is also that the user specified parameter, right? So based on this EPS and the mean PTS value, whatever data points are there in our data set, they are classified into three types. One is your core data point, second one is border point, third one is outlier. So when is a point is said to be a core point? If a point is a core point, is a core point if there are at least mean PTS number of points in its surrounding. So mean number of points are there in its surrounding with radius EPS, because APS we have considered as the distance for the neighborhood, right? And the border point, it is a border point if it is reachable from a core point, right? But there are less number of mean PTS number of points with its surrounding area. And outlier, that is neither a core point, neither a border point, right? So a point is an outlier if it is not a core point and not reachable from any core points. So generally the outliers, it will not form clusters in this DB-scan algorithm, right? So they will be separated from the remaining points in the data set. So let us see this diagram. If you see, if these are the right 6, 7, 8 data points are there in our data set. If you see, right, suppose the EPS value will consider something. So these points, these are neighbors, right? These red points are said to be as neighbors of each other. So these are the core points. So they will form the clusters, right? This point B, C, right? These are the boundary points. So they are reachable from the core points, but they don't have mean PTS number of points in their neighbors because they don't have any neighboring points for the B and C, right? So here N is the outlier. Neither it is a core point, right? Or neither it is a border point. So this is the outlier. So this outlier will be separated. Or you can form a cluster containing the outlier data points in the data set. So in this way, depending upon your EPS value and the mean PTS value, you can define the core point, right, border point, and the outlier or the noisy point in the data set, and you can divide the data points or the partition the data set into number of clusters, right? So simple two steps are there. You have to initialize the mean PTS and the EPS value. So randomly you can consider a starting point as the starting point, right? Out of n points, any point you can consider as a starting point. Randomly you can select, and its neighborhood area is determined using the radius EPS. So you have to see how many neighborhood points are there for the starting point, right? If there are at least mean PTS number of points in the neighborhood, so that is a core point, because we have seen the definition of the core point, right? So from the core point, the cluster formation starts. Okay. If that is not a core point, the point is marked as noise. Okay. So once a cluster formation starts, we are forming a cluster with the core point. What we have to do, all the points neighboring to that core point, they will become the part of that cluster. Okay. So if these new points are also core points, again you have to find out the neighboring of those core points, and they will be added to the cluster A. So this process you have to repeat until all the neighborhood points of the core points are added to that cluster, right? So you have to randomly choose another point among the points that have not visited in the previous step, like your DFS or BFS you are doing in the graph data structure. Like same thing, you have to any points remaining that doesn't belong to the cluster. Again, randomly you choose another point, okay, that are not visited, and you have to apply the previous step. So this process is terminated when all points are visited. So all points are visited means the points are becoming to one cluster, right? So here the outliers, they will form a separate cluster here. That is the process, because these outliers data we are unable to handle in the previous, right? Either k-means clustering or agglomerative or divisive clustering. We are not handling this outlier or the noisy data. Whereas in the density-based DB-scan algorithm, we are able to handle identify the outlier data, and we can form a cluster containing the outlier data only. So this is
बंद कर दूंगा.
Yes, anybody wants to ask anything?
चैट प्रश्न आता ही नहीं है. ये इन कॉल ये chat.
Okay. Please mute yourself. I request the participants, please mute yourself. If you are having any doubt, you will unmute yourself and ask. Okay. So advantage of this DBSCAN algorithm, it doesn't require a prior specification of the number of clusters, right? And it able to identify the noisy data whenever you are clustering. Okay. So this algorithm is able to find the arbitrary size and arbitrarily shaped clusters. Disadvantage is that, right, this algorithm fails in case of varying density clusters. If the points are not neighboring to each other, right, in that case, it will unable to form clusters, right? So next, after this density based clustering algorithm, let us discuss some graph based clustering. So there are different types of graph clustering algorithm. Spanning tree is there, shared nearest neighbor is there, betweenness centrality based algorithm is there, highly connected component, maximal click enumeration, kernel KME. So different algorithms are there. So I will briefly tell about this case spanning tree and the shared nearest neighbor clustering algorithm, how we can use to form clusters among the data points. So graph clustering, right? If you are able to present your data points in a graph, you can go for the graph clustering, right? So in the graph clustering, there are between graph clustering concepts are there and within graph clustering is there. So between graph clustering methods, right, you divide a set of graphs into different clusters. So you have to decide, right, what you want, right? What is there in your data set and how you want to cluster the data. For example, a set of graphs represents, suppose, the chemical compounds that can be grouped into cluster based on their structural similarity. Right? For each chemical compound, we are having a graph and we are going to cluster the chemical compounds having the same structure. Okay? So in that scenario, you can go for the between graph clustering methods. Second one is within graph clustering. Right? So within graph clustering method, what it will do, it will divide the nodes of a graph into clusters. So we are having a graph. Suppose this graph we are having 5 nodes are there. Suppose the edges are like this. Okay. So we are going to form the clusters among the nodes. That means we are partition the nodes into number of clusters. So that is called your within graph clustering. So I will tell about how this within graph clustering you have to do by using this minimum spanning tree and the shared nearest neighbor concept. Okay. So this within graph clustering, suppose you are having a social networking graph, you have to cluster or represent people with the same or similar hobbies, right? So if you are representing the people by one node, okay, then you can cluster the people having same or the similar hobbies into same clusters. Right? So how to do this within graph clustering? So first one is, this is the minimum spanning tree based clustering, right? So what is this minimum spanning tree? Suppose we are having a graph like this. Suppose simple, this is we are having a graph. Suppose 1, 2, 3, 4. Like this, if we are having a graph, this is a graph G, right? So we have to construct its minimum spanning tree. So what is the spanning tree? The spanning tree is a subgraph of the graph G, which is having same number of nodes as in the graph G, but less number of edges than the G. So generally n minus 1 edges will be there, minimum n minus 1 edges will be there in the spanning tree. Right? So this is a, you can call this is a 1, 2, 4, 3. You can call this is a spanning tree of the graph, right? Similarly, 1, 2, this is 3, This is 4. This is also a spanning tree of the graph, right? So there are different combination possibility of finding the number of spanning tree from a graph. So if you have done the data structure or the graph data structure you have studied, maybe you have right, you know about the depth first search, breadth first search, right? If you apply DFS to a graph, depth first search to a graph, you can get the DFS spanning tree, right? And if you go to the DFS algorithm, you know, right, depending upon the static vertex you are choosing and the order in which you are visiting the vertex of the nodes, it will form a different set of visited nodes, right? So those many spanning tree also you will get if you perform the apply the DFS on this graph. Similarly, if you apply the breadth first search on the graph, you will get the BFS spanning tree. Okay, so depth first and the breadth first search you can apply to find out the spanning tree of a given graph. And how to find out the minimum spanning tree? You have studied, I think, in the data structure or the algorithm analysis. So minimum spanning tree, right? Minimum spanning tree you can find out from a graph. There are two algorithms are there. Your Prim's algorithm is there. Okay, and there is your another algorithm, Kruskal algorithm is there. So you can go through these algorithms. So this algorithm, what they will do, they will take a graph as the input, and what is the output? Input is graph, output will be your minimum spanning tree, MST. Okay, so minimum spanning tree means the spanning tree you are getting from the graph which has minimum cost. So here the graph is a weighted graph, right? That means some weights or some cost is associated with every edge of the graph. So whatever tree you are getting at the end, the cost of those edges will be minimum. So that is the MST concept. So I am not going to discuss about how this Prim's algorithm works, how this Kruskal algorithm works, right? So if you are representing, so here you are having that, you are having the data, number of data points D, right? So you are able to represent your data points in a graph structure. This is the graph G. Then you apply the Prim's algorithm or Kruskal algorithm, you will get a minimum spanning tree. Okay, so I am assuming that you know up to this one. If you are having the minimum spanning tree, next what you have to do, or you have to cluster. You have to apply this MS-tree clustering approach to find out the number of clusters. So which data points are coming to which clusters. So how to find out that one? That I am going to discuss here. So assume from the given graph, you are able to construct or you are able to represent your data points in a graph, and you have applied the minimum spanning tree algorithm, right? And you got this MST, minimum spanning tree. So in this tree, there are 5 nodes are there, and the cost or the distance or the weight you can call, that is the between every edge is given. Okay, so here in the minimum spanning tree clustering, what you will do, user has to specify the k value. Okay, how many clusters user wants, right? Suppose I want 5 clusters. So in these 5 clusters, which data points are coming? So data points means each data point you are able to represent through a vertex or through a node in the graph, right? So this is the given. So for this minimum spanning tree, you are specifying the k value. So what it will get? This output you will get as the k groups of non-overlapping vertices. I mean you are getting k clusters here. So which data points are coming under which cluster we have to see. So for that, what you have to do, by getting the minimum spanning tree from the given graph by applying the Prim's algorithm or the Kruskal algorithm, what you have to do here, 1 minute. Okay, so you obtain the MS-tree of the input graph G. So these are the simple steps. Next, depending upon the k value, okay, you have to remove the k minus 1 heaviest edges from the MS-tree. Okay, so heaviest edges, how will you define? The more cost, right? Heaviest edges means with respect to cost or with respect to weight, whatever is given for the graph. From that value, you have to remove k minus 1 heaviest edges from the MS-tree. So it will result in k clusters. Now we'll see how for this MS-tree, if you take some k value, we'll see which nodes are coming into which cluster or how they are participating. Okay. So assume this is the MS-tree we are getting from the given graph. So we are having, suppose the k value, user specified k value is 3. So what we have to do? Remove k minus 1 heaviest edges, right? So 3 minus 1 means 2 heaviest edges we have to remove. Okay. Now if you see, so the edges are 2, 3, 2, 4. 4 edges are there. Out of 4 edges, the value cost of the weights are 2, 3, 2, 4. So if you arrange as per your descending order, so 4, 3, 2, 2. Right? So 3 minus 1, 2 heaviest edges will be removed. So these edges, 2 edges will be removed. So this edges, now you see, this is the 4, this is the 4, this is the 3. So this uh, 2 edges you have to remove from the given graph. Now what you are getting, now you see, you are getting, this is one component, this is one component, this is one component. So how many clusters you are getting? 3 clusters you are getting. So one cluster C1, it contains the vertex 2 or the node 2. Another cluster C2, it contains the node 5 or the vertex 5. And the cluster C3, it contains the remaining vertex 1, 3, 4. Now, whatever number of clusters we want, those many clusters we are getting after removing k minus 1 number of edges, k minus 1 number of highest wedges from the given graph. So, in this way, you can apply the MST based clustering approach to partition your data into number of clusters, right? For that, you have to know the Prim's algorithm and the Kruskal's algorithm to find out the minimum spanning tree. And the basic idea is you have to represent your data points through a graph. That is the problem. Okay. Second one is, so this is one of the graph clustering algorithm. This is also the within graph clustering, shared nearest neighbor clustering. So in the SNN clustering, what you have to do, that is the shared nearest neighbor clustering approach. This is used. Okay. So if this is the t value, again, this is a user specified value, t value user has to give. And if this t value is known, what you have to do, this clustering, it will divide the data into t number of clusters. Okay. So for that, this is also a very simple step. For a given graph, assume you have represented your data points and number of data points through a graph, having the weights or having the costs associated with each edge. Right? You have to obtain the shared nearest neighbor graph of the input graph G. So you have to convert your graph G into a SNN graph, shared nearest neighbor graph. Right? Then what you have to do? You have to remove edges from the SNN graph with weight less than t. As I told, this is a t is a user specified value. So the edges which are having less than t value, you have to remove those edges and you will get t number of clusters here. Now see how to construct this SNN graph from a given graph. Right? So the shared nearest neighbors concept is that, so the SNN, this is a proximity measure and denotes the number of neighbor nodes common between any given pair of nodes. So the SNN value between every pair of data point you have to find out. So what is that? So the SNN value, shared nearest neighbor between X and Y data point, will be the number of neighbor nodes common between any given pair of nodes. How many nodes are common? Neighboring nodes are common between this XY. Suppose 2 nodes are common. So 2, this value, SNN value between X and Y is 2. Right? So in this way, you can represent a graph into a SNN graph. Now let us see, we'll take a simple graph and how to find out or how to convert the SNN graph from the given graph, we'll see. Suppose we are having an input graph G. This graph is given for as every edge, right? UV, some weights are given. Okay. So the number of shared nearest neighbors U and V is how to find out. Now see, this is the graph. Now this is the SNN graph. So SNN graph you have to convert from this graph G. How to find out? Now see the same vertices you are keeping 0, 2, 1, 3, 4. Now between 0 and 2 you see. Between 0 and 2 how many common nodes are there? Neighboring nodes are common. For the 0, 1 is 1. Right? For the another node is 3. Then for the 2, right? 1 is there, 3 is there. So how many nodes are common? 2 neighboring nodes are common. So the SNN value between 0 and 2 is 2. Similarly, between 0 and 1, 0 and 1 you see 3, 2 both are common. So 0 and 1 this is 2. Similarly, 2 and 4, 2 and 4, you see, only 1 is common, 3 is common, right? So the SNN value between 2 and 4 is 3. Between 2 and 3, you see, this is common, this is common, this is common. 3 are common. That's with 2 and 3, this is 3. Let us see between 1 and 3. 1 and 3, if you see 1 and 3, what is there? Between 1 and 3, this is only common, 1 and 3. Okay. So what we have to do? This is the SNN graph you are constructing from the given graph. Okay. Then what you have to do? You have to assume the t value, right? Suppose t equals to 3. Okay. So if U and V share more than t neighbors, then place them in the same cluster. That is the meaning. Okay. So this is whichever value. Okay. So we have to discard the edges which are coming your less than t value. So you will get here 0, 1. This is one cluster. Okay. This is one cluster. This is one cluster. This is one cluster. So you will get more than t number of clusters also in the SNN graph. It depends upon, all right, how many sharing nearest neighbors are there between every pair of nodes. So for this given data set, for the given graph now, if you do this within graph clustering by using the shared nearest neighbor concept, you will get 4 number of clusters, right? So in this way, if you are able to represent your data set into a what you call that is a graph, then you can apply the MST or the SNN, or there are other several techniques are there for the graph clustering. You can apply those techniques to form the clusters out of the given endpoints. Okay, so this is all about your whatever clustering we have discussed. Those are your crisp clustering or hard clustering, right? So we'll see if you know the fuzzy set, okay, where your fuzzy clustering or soft clustering we can use. So here we are seeing whatever we are discussing, a data point. Suppose we are having n number of data points, okay, and we are having suppose 3 clusters, C1, C2 and C3. Suppose we are having 9 points are there in the data set. Okay. So assume cluster 3, it contains 5 points, cluster 2 points, 2 points, and clusters 3 contain 2 points. Right. So the these 5 points, suppose your point P1 to P5. This is P6, 7, this is P8, 9. So P1 to P5 completely they belong to the cluster C1, right? They do not belong to the cluster C2, or they do not belong to the cluster C3. So the membership of this P1 to P5 with respect to C1 is 1, whereas the membership of these 5 points with respect to C2 and C3 is 0, because they don't belong to the cluster 2 and the cluster 3. Similarly, for the cluster 6 and point 6 and 7, they belong to the cluster 2. So the membership for 6 and 7 with respect to cluster 2 is 1, whereas the membership of point P6 and 7 with respect to C1 and C2 is 0. Right? They belong to only one cluster. Okay. So those clustering, whatever we have discussed, these are called your crisp clustering or hard clustering. So when we can use this crisp clustering or the hard clustering, if our data are distributed in well separated groups, we can go for this crisp clustering or data clustering. Okay. If the data are not partitioned into well separated groups, right, then in that scenario, we can use the fuzzy clustering or the soft clustering. So what it happens? It happens that point P1 and P2, it belongs to the cluster C1, as well as they belongs to the cluster C2, as well as they belongs to the cluster C3. But the membership is changing, right? Maybe they belongs to more, their weightage is more towards the cluster C1, less towards the cluster C2, and minimum towards the cluster C3. So we are giving some weightage to the weightage of that point with respect to that cluster. So that is called your fuzzy clustering or soft clustering. So in this situation, what we are going to do, it might be more appropriate to assign each data to each cluster that indicates the degree to which the data belongs to the cluster. That means every point is belonging to these 3 clusters. There are 3 clusters if you are assuming. So point P1 is belonging to the cluster C1, it is belonging to the cluster C2, as well as it belongs to the cluster C3. But the degree to which it belongs to that cluster, it's remains changed, right? So more degree, we are concluding that the point is belonging to that cluster, but it has some membership to each and every cluster present in the data, right? So this, for that we have to see the fuzzy concept, right? So this is a fuzzy set or the fuzzy concept for the imprecise data. This was introduced by Professor Lufti Jade in 1965, right? So we are not going to discuss about these fuzzy sets, only whatever I told you. So the membership value for the points with respect to a cluster, it will be either 0 or 1. So this is called a crisp clustering or hard clustering, right? But the membership value or the membership of a point with respect to a cluster, if is in the range 0 to 1, right? It is belonging to the cluster C1.98 and it is belonging to the cluster C2.02. Right? So the total sum should be 1. Okay. So then we can conclude that point P1 is belonging to the cluster C1, but it has membership with respect to C2 itself. Right. So how to do this fuzzy clustering? I mean, how to define or how to assign these weights in the range 0 to 1 for every point with respect to the every cluster. Right. So here again, like this is the right, K-means clustering, whatever we are doing, same thing we are doing in the fuzzy clustering. If you remove the weightage, right, if you consider the weightage as 0 to 1, either 0 or 1, it will become the K-means clustering. If you consider the weightage in the interval 0 to 1, it will become the fuzzy clustering or the fuzzy C-means clustering. So how to do this one, right? Suppose we are having some data points, n number of data points are there, and suppose we are assuming that we want k number of clusters out of this n points. So which data point will go to which cluster? So that is our target. So how to solve this problem? By using this fuzzy C-means clustering, right? So simple, this problem is also very simple. Only two mathematical notations are used. Like in the K-means clustering, if you remember what we have done, we have arbitrarily chosen 3 clusters. Then we have changed the cluster centroid, right? And then we have reassigned the points to the clusters. Every time the cluster centroid is changing. Here also, what we'll do? We'll do this weightage or the membership weightage we are going to update, right? So that for that we have to see this fuzzy clustering algorithm. So the fuzzy clustering or the FC means, so we are having n number of data points, assume, okay, and suppose these data points are x1, x2, xn, and suppose k is the user specified value, c1, c2 up to ck, okay, and assume d is the dimension of the attributes, how many attributes are there in the data, if d is the dimension attribute, right? So x1 is data point, this is represented by x11, x12, x1, sorry, this is capital X1, okay, x11, x12, xn, they all are capital. So with respect to dimension, this is x11, x12, x20. These many attributes are there. So these are the notations we have to follow. Membership weights are Wij, right? So this is what it represents, Wij, membership or weightage of data point I to cluster J. So what is the membership in the fuzzy clustering? In the interval 0 and 1 we are giving. So this thing we are going to define. That means the point which is having, that means every point is having some membership with respect to every cluster. So the maximum membership weights, right, that will be considered or that will determine which cluster the point is belonging. Okay, so how to define this membership weights, how to update this membership weights, these are the two mathematical equations we have to use for doing this fuzzy clustering. Okay. So let us solve this problem through a small example. Suppose we are having 4 data points, right? N equals to 4, and we are having, we want to cluster these 4 data points into 4 clusters, right? So we'll consider the whole problem will solve by using k value equals to 3 and more data points we'll consider. So what we'll do, how this weight matrix or the membership matrix looks like, you see, right? So there are 4 data points, right? We are having 4 data points, 1, 2, 3, 4, and we are having 4 clusters, C1, C2, C3, C4. So this is the layout of the weight of the membership matrix. So what this value, this entry represents, now the membership or the weightage of the point x1 with respect to C1 is 0.02, with respect to point C2 is 0.03, with respect to C3 0.01, with respect to C4 this is 0.94. If you add these values now, the summation it will be 1. So the total weight will be 1. Similarly, for the x2, this will be 1. For this 3, this will be 1. For this x4, this will be n. So this is the weight of the membership matrix. So initially, this weight is, right, randomly you have to initialize, such that what is the constraint you have to follow? You have to follow the constraint that total summation of the weights of the membership values should be 1. Because our target, right, in the range 0 to 1. Our lower limit is 0, upper limit is 1. So in this way, your weight and membership matrix looks like, right? So what it means, suppose we are applying this fuzzy C-means, we'll discuss the steps of this fuzzy C-means. So suppose after applying the fuzzy C-means clustering, we are getting this is as the final membership matrix. So what we can conclude, X1 belongs to which cluster? As the membership of X1 is more with respect to cluster C1, X1 is belonging to the cluster C4. What about X2? X2 again, right, C4, this is belonging to cluster C4. X3, this is belonging to the cluster C3. X4, again it is belonging to the cluster C4, right? So we are able to convert this data point, 4 data points into 2 clusters only here, right? Because depending upon the membership matrix, right? So how to apply this fuzzy C-means and what are the steps we have to follow? How to change the centroid of the clusters in the fuzzy C-means algorithm and how it is similar to the K-means algorithm, we'll see here, right? So what is the input? Your input is having your data having n points and K is the cluster. How many cluster you want? So what is the output? Output is this the weight matrix or the membership matrix. This matrix we want, okay? So where Cj, right? Your Cj is the clusters for 1 to I range will be 1 to n number of data points and J is for clusters 1 to K. So we are having the data points and the K number of clusters we are providing as input and output will get as the Wij matrix for each data point with respect to each cluster. N represents the number of data points, K represents the number of clusters. Okay. So what you have to do in the step 1, you have to randomly assign the weights Wij. So Wij means ith point, weight of the ith point with respect to the jth cluster. That is the notation. Next, what you have to do, you remember the K-means clustering algorithm. Randomly, you have chosen K number of points, right? And you have calculated the centroid. Next, you have reassigned the remaining objects to one of the cluster. Again, you have updated the centroid. Same thing we are doing here, but here we are updating the weight matrix. Okay. So we have randomly assigned the weight matrix. Second, we have calculated the centroid of each cluster using the fuzzy pseudo partition. So this is one mathematical notation you have to use here. Then we have to calculate the Wij assignment step we have to do. We have to update. This is the not the this is the update. Update or Wij. So how to update the Wij? So one fuzzy pseudo partition is there for calculating the centroid. Next is your how to update the weights. So these are the two mathematical equations you have to follow in the FCM. So step 2, 1, 3 you have to repeat until your centroid doesn't change. Or the convergence criteria already we have discussed, right? In the K-means clustering, same convergence criteria or the termination criteria you can use for termination, right? Now let us see one example we'll see and how we'll see how it works. So here as right your sum of squared error for the fuzzy C-means clustering can calculate as summation of j equals to 1. This is for number of clusters. This is for number of points. Summation of I equals to 1. So this is the weight matrix Wij. So ith point with respect to the cluster j. What is the membership or what is the weight? So this is the P, power P. P is the influence of weights into distance of xi and cj. What is the distance of the point xi with respect to cj, right? So this influence of weight metric, weight value, that is the P can be taken as 1 to infinity in the FCM. Okay. If you consider the P value equals to 0, it will become the K-means clustering algorithm. Okay. So what you have to do here in the FCM, we have to randomly select the Wij where the constraint is that summation of all the membership values with respect to a data point and with respect to all the clusters, it should be 1. Summation of j equals to 1, Wij will be 1. Next, what we have to do, you have to compute the centroid of the clusters. So how to calculate the centroid of the cluster? So this is the equation you have to follow to calculate the centroid. So Caj, right? This equals to summation of I equals to 1 to 1 Wij to the power p xi divided by summation of I equals to 1 to n Wij p. Okay. So if p equals to 0, you will get this p equals to 0 value we will give here. Then this k, it looks like your k means clustering. K means clustering, how you are calculating the centroid? Summation, that is average you are calculating. Average of all the attribute values. It will become p equals to 0 means it will become the k means clustering. Okay. Next, once you have updated the centroid, you have to update the weight matrix. So weight matrix you have to update like this. Wij will be 1 by distance of xi cj, point xi with respect to the cluster cj, whole power 1 by p minus 1. This is the p is the weight influence, right? Divided by summation for this factor for all the clusters. J equals to 1 to k for same value that is, right? So here what will happen? The more distance, right, the less weight you will get. So the more distance, the distance is more. Suppose we are having the p equals to 2, right? If you apply, consider p value equals to 2, then the Wij will be calculated by as 1 by distance of xi cj divided by summation of 1 to k distance of xi qk, cq. Okay. So what you are getting here? If the distance xi cj, the distance between the point xi and the cluster cj is more, the wij will be less. If wij membership will be less, what it means, right? That means its membership towards that cluster is very, very low, right? If the distance is very less, that means its membership will be, or the weightage will be very high. That means that point will belong to that cluster. So in this way, the fuzzy clustering, right, depending upon the p value, right, it is similar to your k means clustering, and p value if you are taking greater than 0 means it has some influence on the weights, so it will become the fuzzy means clustering. Okay. And now let us do this small example. Suppose we are having 4 data points. Okay, so we'll consider the number of clusters is less than the number of data points, right? So that we can group the data points among these 2 clusters. So here there are 2 attributes. So the dimension of the data is 2 here. This is the attribute A1, this is the attribute A2. Okay, so the values are 1, 2, 2, 3, 9, 4, 10, 1. So assume you are here n equals to 4, dimension d equals to 2, k number of clusters equal to 2. And suppose your weightage influence, right? P we have considered as 2. Okay. So how to cluster now the data points? Now let us see. So what you have to do, you have to step 1, you have to initialize the weight matrix. So what is the weight matrix? Weight matrix will be ith point to the jth cluster. So there are 2 clusters, C1 and C2. There are 4 points, X1, X2, X3, X4. So this entry, this represents the membership of the first point with respect to cluster C1. This is the membership of the first point with respect to cluster C2. So that constraint I told you, the summation should be 1. So this is the initial assignment only. So you can initially initialize this weight matrix. Only this condition you have to follow, summation should be 1. Here you see this will be 1 also, this is also 1, this is also 1. So this is the initial weight matrix. Then what we have to do, right? We have to calculate, right? We have to calculate the centroid of the clusters now, right? So what is the centroid of this cluster C1 and C2? We have to calculate. So how to calculate? For that, this is the formula we have seen in the FCM. So Cj we have to calculate as summation of I equals to 1 to n Wij p. So p value, weight influence we have considered as 2. So you can go for higher values on p, and you can see how it impacts on the cluster formation for your particular data set, right? So xi divided by I equals to 1 to n Wij p. If you consider this p equals to 0, it will become is your k means clustering, right? Now what you have to do, p value is 2. Now you see wi1 square, right? Summation of I equals to 1 to n wi1 square. What is this? That means this one. 0.4 square plus 0.88 square plus 0.41 square plus 0.27 square. So this is the summation of wi1 square. ith point with respect to the first cluster. This we are getting 1.18. Similarly, ith point with respect to the cluster 2. Summation of all the points with respect to the cluster C2. 0.6 square, 0.12 square, 0.59 square plus 0.73 square. So summation of I equals to 1 to 2 square equals to 1.25. From where we are getting, if you do this calculation, you will get this one. Okay. Next, by using this value, now you have to calculate the centroid, right? So the centroid, this is the formula you have to use, right? Only we have calculated this one, this lower part we have calculated. Now we'll go to the upper part. So there are two clusters C1 and C2, but we are having two attributes, right? So centroid will be C11, C12 for the cluster C21, C22. So how to calculate the C11, right? For the cluster C1. So this is the, if you go to this formula, Wi, summation of Wij into Xi. What is Xi? Xi is the data point. This is the data point. Data point we have considered 1, 2, 4, 1 to 9, 10 for the first cluster, first data point. Second is attribute to 2, 3, 4, 1. Okay. Now if you see here, now this 0.4 square, that is the Wij. Okay. Into 1, 2, 9, 10. This is the Wij. This is the point 1, 2, 9, 10 with respect to the first attribute. Similarly, same Wij value with respect to the second attribute 2, 3, 4, 1. So if you calculate, you will get C11 divided by Wij square, this value, this formula. Okay, already we have calculated 1.18, 1.25. So you will get C11 is 3.38, C12 you will get 2.88. Similarly, you can apply the same procedure for the cluster 2, because cluster 2 your weights are different, right? Points are 1, 2, 9, 10, 2, 3, 9, 4, 1, but these weights are different. So you will get C211 similarly here. The 0.6, 0.12, 0.59, 0.73. These weights are different for the cluster 2. And these are the attribute 1 value 1, 2, 9, 10. Here 2, 3, 4, 1. So you will get the cluster, right? Centroid for the cluster 2 was 7.02, 2.14. So these are the cluster centroid you are getting after applying the Fuzzy pseudo partition. Okay. Next, what you have to do in the step 3, you have to update the weight matrix, because your target is to how to, depending upon the weight matrix, you can take some decision, right? So for calculating the weights, right? So Wij, the value of this updated weight will be the reverse reciprocal of distance between the Xi and Cj to the power 1 by p minus 1. That is the influence factor, weightage influence factor, divided by summation of, for all the clusters, same value you are taking. For all the clusters, summation of all the clusters, reciprocal of distance between the each data point and the cluster, and to the power, that is the influence factor 1 by p minus 1. So how to find out that one? So we are having the data points x1, x2, x3, x4. These are the 4 data points are there with respect to 2 attributes a1 and a2 is there. These are the 2 cluster centroid we have formed here, C1 and C2 in the previous step. C11, C11, C12, C21, C22. We have formed. These are the values you got. C11, C12, C21, C22. So what we have to find out? We have to find out this one, distance between Xi and Cj. So what is the distance between the data point 1 with respect to the cluster 1? What is the data point distance between the data point 1 with respect to cluster 2? Right? So these are the centroid. This is the data point 1, 1, 2. These are the values. Here this is the 3.38, 2.28. Cluster C1, right? So you apply the Euclidean distance formula, you will get the distance 2.54 between this and this cluster C. Similarly, for the point x1, this is x1, x1, x2, x3, x4. Similarly, you can find out the distance between the cluster C, data point x2 and the cluster C1. You will get 1.38. Distance between the cluster data point x2 and the cluster C2 will get 5.10. Similarly, the distance between data point 3 and the cluster C1, 6.88 you will get if you do the same calculation, Euclidean distance. And the data point, right, fourth data point with respect to the what you call that is the cluster C2, you will get 3.19. So initially we have randomly we have initialized the weight matrix, right? This is the weight matrix we have initialized, and after applying the FCM, fuzzy C means steps, we have to get another weight matrix, right? So what is the how to find out that weight matrix? So this is the distance between the data point and the cluster centroid we have determined. So we have to update this weight matrix by using this formula, right? So how many weights will be there? 8 weights will be there, right? W11, W12, W21, W22, 3132, 4142. So for getting those values, we have to apply this formula. Here how to find out this W11? W11 is reciprocal of, because P value we have considered as 2, right? So the power of 1 by P minus 1, it is coming 1 only. That's why W11 is reciprocal of distance between points x1 and the cluster C1 divided by summation of reciprocal of distance between x1 with respect to C1 and x1 with respect to C2 for all the clusters, right? So if you solve, because these distance values are there in this matrix, you will get all the values. So for C1 you are getting 2.54, so 1 by 2.54 divided by, divided by, divided by 1 by 2.54 plus 1 by 6.03, right? If you solve, you will get W11 equals to 0.7, right? Similarly, W12 for the cluster C2, right? So cluster C2, 1 by 6.03, 1 by 6.03 divided by this is the same value, 1 by 2.54 plus 1 by 6.3. So you will get 0.6. So this is also without doing this calculation also, now you can conclude that if this is 0.7, this will be 0.3, because the summation we have used the constraint equals to 1, right? So for cross verification, if you have done correctly the calculation or not, if you calculate this one and if the sum is coming 1, that means your calculation is correct only, right? So this is the modified weights, right, for the data point x1 with respect to the cluster C1 and with respect to the cluster C2, right? For the cluster C1, it is 0.7. For the cluster 2, it is coming 0.3. Similarly, we have to calculate the W11, W12 we have calculated. So we have to calculate the W22 for the point x2, 31 and 32 for the point x3, 41 and 42 for the point x4 by using the same formula. Okay, so by using the same formula, but the distance value is different because the distance between every point and the individual cluster is there in this distance matrix. So after calculating those weight matrix, you can represent through a tabular structure, similarly way. There are 4 points, clusters C1 and C2, and at the end you will get all the summation will be 1 only. You can cross verify. If this is, you are getting 1, that means your calculation is correct, right? So this is the first iteration of the FCM, right? So by using this weight matrix, again you repeat the procedure, right? You have to repeat the whatever steps we have done. We have calculated the right centroid of the clusters, right? Next, what we have done, we have calculated the distance between the each data point and the cluster centroid. Then we have updated the weights. So these 3 things we have done. So these 3 steps you have to repeat until your termination criteria is satisfied. So the termination criteria, as we have discussed in the K-means clustering, it may be the number of iterations. There may be no change in the weight matrix, right? So in that scenario, you can terminate. So assume after doing 5 iterations, maybe suppose that we have considered as the number of iterations equals to 5 for our FCM, and we are getting this weight matrix, right? So what we have to conclude now, because our target is to find out the data points belonging to which cluster. If there are 2 clusters C1 and C2, so if this is the final weight matrix we are getting after 5 iterations, so what is there in the point C1? This is the cluster C1, this is the cluster C2. So under C1, which point you are getting? X1 you will get under cluster C1, X2 you will get under cluster C1, right? And X3 and X4, they will go to the cluster C2. right? Now you are having 4 data points and we are having 2 clusters. So X1 and X2 are forming or coming under the cluster C1, and X3 and X4, these are coming under cluster C2, right? So this is the way by which you can partition a set of data points, right? By using this FCM. If your data points are not well separated, right? So you have to go for this soft clustering or the fuzzy clustering, and at the end you will get the clustering, right? Which point is coming to which cluster, right? So these are some of the clustering approaches. So we discussed about the K-means clustering, right? We discussed about the different hierarchical clustering, agglomerative, and this divisive. And from the agglomerative and the device, how to construct the dendrogram, and from the dendrogram, how to find out the number of clusters. Then we have discussed one density-based clustering algorithm, that is the DB-scan algorithm, how to handle the outliers in the data point, right? Next, we have discussed some graph-based clustering approaches by using the minimum spanning tree and by using the shared nearest neighbor concepts, right? So within graph clustering, I told you. And then we have discussed this fuzzy C-means clustering when your data points are not well separated. In that scenario, you can go for the soft clustering or the fuzzy clustering, where you are determining the membership of each data point with respect to each cluster, right? So have the end in the FCM, if you will get the weight matrix, right? So you can assign the cluster number to the data points like this. So in this way, your n number of data points, if you are having n number of data points and you are having k number of clusters, so you are partitioning, right? Or you are grouping the n number of data points into k number of clusters, right? So these are some of the applications of the clustering, right? So for your domain, right, if you are having the data set and you want to apply the unsupervised learning mechanism, you want to cluster the data. So depending upon your data set, you find out a suitable clustering approach and you can cluster your data, right? So these are the some potential applications of this clustering: your satellite image data clustering, medical diagnostic systems, text data clustering, right? So some of the applications of for this image clustering for emotion classification from speech, your market segmentation. These are the from various domains only I have listed, right? So for your particular domain, we can find out what are the applications of this clustering approaches, right? Social network analysis, and the computer organizing the computer clusters data centers, right, for network layout and the location, astronomical data analysis for understanding the galaxy information. You can use also the different clustering approaches, okay? So these are the some of the references I can go through, and there are many more clustering approaches are coming for different applications. You can go through those techniques. So this is all about from my side about the clustering approaches. If you're having any doubt or anything you want to ask, you can ask.
Hello,
Yes, sir.
ma'am. Actually, can you suggest any good books for referring all these in the detail? Although you explained very well uh, every algorithm, so can you suggest the good books for all these things, ma'am?
Oh, only for clustering. Okay, I will find out a suitable book and I will tell to the coordinator, right? Because I have collected this material from several research papers only. I will tell the name of the book exactly. I forgot for clustering only. No, I will tell to the coordinator.
Like K means clustering and K means algorithm, agglomerative, and
Hmm.
all this.
Yes,
Yes, ma'am.
yes. I will inform. I will tell the name of the book to the coordinator.
Okay, ma'am. Okay.
Okay, okay.
Thank you.
Thank you, madam. So
Okay.
we'll start the next session at 5.
Okay. Thank you, all the participants.
Good evening, everyone. Can anybody respond? My screen is visible?
Yes, sir.
Yeah, okay. Thank you. So I welcome all of you to the second session of basics. In this session, we'll discuss about one of the case study of artificial intelligence, you can say, or you can say machine learning, or you can say data science as well. And the topic name is recommender system. So this case study is will covered in two different lectures. One lecture is today, another lecture in the last day. So we'll see some also hands-on related to the recommender system. So for this hands-on, you can use any traditional programming language or recent programming language like C, C++, Python, Java, any language you are comfortable. You can use those language to write the code for a recommender system. And if you are not comfortable in any this programming language and you are a non-CS background person, then you can write the code in Microsoft Excel as well. But you have little bit expertise in the Microsoft Excel. So there also you can write the small code related to the recommender system. Now, what comes to our mind when we say recommender system? Like as we all are belongs to academics or industry persons, so we write the recommendation letter for our student, our fellow colleague, or as a employer you are writing for your employee. So in that recommendation letter you are writing the key achievements, the strength and weakness of a particular person. Similarly, recommender system is not limited to academic institution or industry, but e-commerce sites like Flipkart, Amazon, or if you go for social networking websites like Facebook and Twitter and other platforms, recommendation system plays a very important role. So we'll discuss this case study in detail. I'll tell you about the architecture. I'll tell you what are the questions related to this architecture. We'll also see how to address these questions by providing some kind of solutions which can help the systems to make better prediction. So these are the topics that we are going to discuss in these two lectures, today's and the last day lecture. First, we'll discuss about introduction to recommender system. So here we'll see what is a recommendation system, what are the major components of the recommendation system. Basically, we'll see there are 4 different components of the recommendation system. And in each and every component, especially we'll focus on 3 different components out of these 4 different components. And these 3 components are having 3 important questions that actually we want to highlight in the part of recommendation system. If you can solve these questions and if you can understand and apply your own methodology, then you can generate better recommendation system. After this, we will focus on different types of recommendation system. Initially, we'll discuss about 2 different type of recommendation system, and further we will discuss another 2 categorization of each and every recommendation system. So total, if you see, we'll discuss about 4 different types of recommendation system. But initially, we'll categorize it to only 2 types. Then once you are comfortable with those 2 types, then we can further see another 2 type of the recommendation system. Next is, once you understood these things, suppose you want to design your own recommendation system. So if you are proposing your own recommendation system, then how you will know that your proposed recommendation system is better in comparison to existing recommendation systems? So for that, you need to evaluate the accuracy of both the recommendation system. So this is same as how we are making assessment for our student. We conduct a series of tests, we conduct vivas, we conduct practicals, lab classes, so through which we are able to see the performance or able to judge a particular student. Similarly, when we go for the recommendation system, we will see how to measure their accuracy, because as a machine learning model, artificial intelligence model, our primary focus is how to improve the accuracy of the model. Then we'll conduct two different activity, as I said, through Microsoft Excel. I'll show you how to conduct activity 1 in Microsoft Excel, and activity 2 you can practice your own in the similar fashion as activity 1. So as we are dealing with a very small example, you can also try this thing by the help of your hand calculation. You can use calculator. Also, you can conduct this activity. This activity will give you the overall idea that how actually the shopping websites and other things are considering different kind of recommendation, suggesting this recommendation to different users. So after that, we'll see some of the similarity functions. This is more about the research works related to the recommendation system, where generally we use some kind of traditional similarity function, but this similarity function has some drawbacks. In order to avoid that, we have some new type of similarity functions that you can use in place of the traditional similarity function, so that you can see the performance of the new similarity function gives more better recommendation in comparison to the existing one. Then followed by we'll see discuss the main conclusion of what we can do in future, and followed by references. So let us start with what is a recommender system. So if you are new to this particular field, while you go through different articles, different blogs, you will find some people refer it is as a recommender system. Some people say recommendation system. Some people say recommender platform. Some people say recommendation platform, recommender engine, or recommendation engine. So all these terms are used interchangeably. You can say one after another, but the meaning is same. Now, especially I want to highlight as a definition that what is a recommendation system. So it is a subclass of information filtering system. So a class means you have, let's say in a class, if you see in our theory class, if you consider a classroom. So in a theory class, let's say we have 60 students, right? So if you want to know the feedback of your class, right? You want to know that whether you have delivered well in the class or not, then you have to take the feedback of the 60 students. Now, while coming to the written feedback, so after your class is over, let's say there is a Google form. Through that Google form, 60 students rate your lecture out of 5. So it is a feasible solution because the link will be sent to all the students, and the students can fill the form through their mobile. But when you come to the verbal feedback in place of written feedback, verbal feedback in place of the written feedback, so you will see in those cases, asking 60 different students about your feedback is very, very difficult, right? Because if they spare, let's say 30 seconds of time to say something about your lecture, then it will take 30 minutes to collect that particular verbal feedback, right? That's why when you go for real life situations, like you talk about Netflix or you talk about Amazon, Facebook, the number of users are very, very high. If the number of users are very, very high, see the performance of each and every student, observe their watching pattern, or you can say observe their browsing pattern. It is very difficult to do that one. So what you can do, rather than focusing on these many number of users, they have taken a subclass. Like in a particular class, as I said, if there are 60 students are there, after the end of my lecture, if I ask 3 of my students to say about the lecture, okay, whether the lecture is good or bad, or it is average. So if I ask 3 students, it is feasible. In the similar fashion, when we deal with recommended system for e-commerce site or social networking website or any application, we consider the subclass of the system. Now, you may ask me a question here that if the class contains 60 different students, then how you have selected 3 students out of the 60 students? There should be some kind of filtering system, right? Which say that by this filtering system, I have selected these 3 students. One of the way you can say I will randomly tell 3 different students to give the feedback. So for a particular user, what the user like, what the user dislike, based upon that, you have to apply some information filtering system, which will help you. Information filtering system will help you to say that these are the products or these are the items that may like by your user. After that also you may get error. If the accuracy is not 100%, definitely you are going to get error, and achieving accuracy of 100% is very, very difficult. So that is one type of defining the recommendation system. Alternatively, what we are doing in this recommendation system, we are predicting the rating or preference of a user, that how much rating, okay, or what is the rating value the user is going to give after purchasing a particular item. Suppose a user has purchased a laptop, right, or a desktop or a computer system, then the recommendation system will predict what is the feedback going to be, what is the feedback the user is going to give related to this particular product, and what is the rating, whether the rating is 4.5 out of 5 or it is 3 out of 5. So such type of prediction we have to make, not only for the purchased item, but also for unpurchased item. Those items are not purchased by a user based upon the historical data or based upon the items that are purchased by the user. I want to see what may be the other items the user may be interested for. So in that case, we are predicting the rating, or we are also looking into the preference of a user would give to a particular item. Here, item does not mean that it is only product. It may be a book, it may be a movie, it may be anything that we consider as an item. Now, if you see the application of recommended system, you will see there are several applications. Like nowadays, we have OTT platforms, we have Netflix, we have YouTube, you have Spotify. So in Netflix, based upon your watching pattern, they are suggesting that as you have watched this particular movie, so this movie, the recently released this movie, you may like for that new movie, right? You may like interested for the new movie. So it is providing you some kind of suggestions. That suggestion is called as your recommendations. That is done by a system or a process or an engine. Similarly, if nowadays or especially in the COVID situations, we are very much habituated with the e-commerce sites. Earlier, those people who are not interested in the e-commerce site, due to the situation, they are now compatible with all the e-commerce sites like Amazon, Flipkart, eBay, and Levi's. These all platforms nowadays, whenever also we are going to purchase some item, we go to the local market and we check the price with the online available in Flipkart and Amazon, right? Just to compare the price, what is there in offline and what is there in the online. So in Flipkart also you have seen while you are purchasing a particular item, it is showing that if you purchase another item, you will get a 5% discount. Or most of the people who purchased this item also purchased the relevant items. So these type of recommendations are generated by the help of recommendation system. Similarly, if you see the example of Facebook, right? If you have saved my number in your contact list, then my number is attached with my Facebook account. So in people you may know, you may find my profile, right? So that type of connectivity is that Flipkart is providing you some recommendation that you may aware of this person, or you may know this particular person, or you may be interested to add this person into your Facebook profile. Like Twitter also having a recommendation system. If you are interested in political news, it is going to suggest you only political news. If you are interested in entertainment news, you will get an entertainment news. Based upon your preference, based upon your previous history, it is going to suggest for one particular item the user, right? Now, coming to a very simple architecture of recommendation system. As we progress, we will see the detailed architecture of recommendation system. In this simple architecture, you can see there are 4 different components. First one, you can say it is an user. We are pointing to a particular user. Let the user is U1. The second component is database, where you can keep the set of items, set of users, the buying patterns of the user, the details about that particular user, details of the item. For those who are not comfortable with the database, you can simply assume that an Excel sheet is also one type of database where you can keep the details of all the user and the details of all the items. The third type of thing is called as the recommendation system or recommendation engine or a platform. It is basically an algorithm or process through which you can generate recommendation for this particular user you want. So let us assume that for this, by using this recommendation system, you have generated 2 different movies for U1. We call these movies as I1, I2 respectively. That is item 1, item 2 respectively. So we are suggesting item 1, item 2 to user U1. User may like this item, whatever you are suggesting, user may dislike, or user may like one of the item you have suggested. So the major component of this recommendation system is that the third component, right? This is the 4th component, but the major emphasis you have to give to the third component. So we call this an intelligent system. If you design an intelligent system, okay, then that system will tell that whatever suggestion you are giving means your prediction. These are nothing but your prediction. The prediction is equal to the actual one. Like if this user U1 is really interested in I1 and I2, then you can say prediction is equal to your actual one. So that's why you need to design an intelligent system which can predict the exact thing for a particular user. So in order to design the intelligent system, what you need? You need machine learning techniques. You have to see various type of machine learning techniques, whatever you have learned, like supervised learning, unsupervised learning, reinforcement learning, any advancement of the learning. Such type of techniques you have to apply because you have the database. In the database, you have the details of the user, you have the details of the item. So using that data, you have to make a correct prediction so that the user will purchase the item. You can increase the profit of a particular e-commerce site. You can increase the number of users in a particular site. That's why specific and generic machine learning techniques you can apply in order to generate the better recommendation. Now, you may ask me that whether recommendation system is related to only e-commerce site or social networking site like that, or you can apply these recommendations in your system in your respective field. Suppose here you can see, for example, suppose you are uh, working for let's say in the field of agriculture, right? In the field of agriculture, you can ask whether we can apply the recommendation system or not, right? My answer is yes. The reason is that suppose you can suggest to the farmer that what kind of crops are suitable for based on their location. Once you look at a particular location, you know what is the humidity, what is the temperature in that area, what is the climate in that particular location, and you can predict that this particular crop is suitable for that location. That is also an example of your recommendation system. That's why the recommendation system is not limited to a particular domain. It can be applied to any domain. Like if you see, we can go for movie domain. So already you know, I have already given the example of Netflix, or you are using Amazon Prime, or you can go for Film Affinity, or you can go for Movie Lens. These are the very popular site where recommendation system plays an important role. Because dealing with a very large number of users is very, very difficult, right? So the solution is that if you can design a particular model, through that model, if you can suggest something, right? You can suggest something. So that can be generalized, right? If you want to design a particular model by looking into a subclass of the user, that same thing you can apply to that entire class, right? But visiting the purchase history of each and every user manually, it is very, very difficult. Similarly, you can see recommendation system can also apply in the news domain. Right? Like different type of news are there, right? News is related to entertainment, news is related to sports, news is related to politics. So one user may be more tends to political news, one user may be more tends to the entertainment news. So based upon the interest of the user, you can suggest some the latest news, or you can say that if a user is interested in political news, recently if something happened in politics, that you can suggest to that particular user. So there also we are applying the recommender system. Similarly, if you go for music domain, like all of you are using Jio, right? Jio mobile operator, if you are using, you have Jio7 app, you have YouTube, right? In Jio7 app, some in these apps also, or these applications or these websites also, you have autoplay option. So once you click the autoplay option, based upon the music which you have listened recently, or based upon your previous history, it is going to play similar kind of music, right? Sometimes also musics are played based upon the location. Suppose you are in the state of Telangana, the local language is Telugu. So you may find the ads related to the some advertisement related to the local language. If you are moving from that location to another location where the local language is Hindi, so you will get in the ad in that particular language. So music domain also you can apply the recommendation system. Now, basically what we want to address in this particular lecture, we want to address three different questions related to three different components. Like here we consider for user U1, later point of time I can consider user U2, then I can consider user U3, like that I can consider up to user UN. Either 10 different users are there. So this is nothing but a set of users, right? Now we will change the user one by one to suggest something to that particular user. That is obvious one. Now coming to this database, we have a very important question related to the database. As I said, database consists of a set of items. It is also contain the properties of those items. It also contains a set of user with their properties, users history, all the things are stored in the database. Now you may ask me a question here, which information do we use to make recommendation? There are several informations are available in the database. Do you think all the informations that are there in the database, is it useful for making the recommendation? The answer is no. You may choose some of the features from the database. You can apply a particular model. Later point of time, somebody can take other features and apply another model. Like that, different people are considering different informations to provide the recommendations. So we will see a set of informations. You have to decide while you are building a particular model that which information you will include, which information you are going to exclude. That is the first question we want to address in this lecture. Second question related to the third component of recommender system, which says that how to implement a recommender system. If you want to decide that how you are going to implement a particular system, obviously you will write an algorithm, you will convert it to a particular code, right? If you look into implementation language, as I already said, you can use C, C++, Python, Java, any particular language. If you are not comfortable in those languages, you can use Microsoft Excel to implement the recommendation system. So we'll see some of the implementation perspective because our activity 1 and activity 2 related to this implementation part. Third one related to the fourth component of the recommender system, which says that how to evaluate a recommender system. Suppose there is a recommendation system you have developed. Now you want to know whether this recommendation system is performing well or not. So for that you need some evaluation. Like if you see our student case, we are conducting, let's say, class test, we are conducting minors, we are conducting mid exams, end exams. By looking into these exams or vivas and other things, extracurricular activity, curricular activity, we say that the student is having good knowledge in mathematics, good knowledge in physics, good knowledge in chemistry, good programming skill, right? So we are evaluating that particular student based upon some parameter. Similarly, recommendation system also you have to do the evaluation. So how to evaluate the recommendation system? What are the parameters you need to consider? What are the performance matrices you have for recommendation system that you have to decide? Not necessarily that all the performance measure you are going to consider when you are comparing your recommendation system with other recommendation system. So I'll address this question first, then I'll address part of this question in the second, then I'll cover this question in third, and again we'll go for the rest of the part of this particular question. So let us start with the first question, that which information do we use to make recommendation? So in order to answer these questions, I have taken a set of items. So I told you a movie is also an item, a book is also an item, a product is also an item. So let us call these items as I1, I2, I3, I4, I5. So these are the 5 different items there in the database. So you know that this particular question belongs to the database, right? So I have taken 5 different items, and I have considered a set of users also from the database. Let us consider 4 different users. One is U1, U2, U3, and U4. These all informations are there in your database. Just you have to decide which information you will consider to make recommendation and which information you are going to exclude. Right? Now a set of items is given to you and set of users is given to you. Let us know the characteristics of different item. If you look into item I1 is a movie. In fact, all the items we have considered here, they are movie. So what are the characteristics of this item? The main characteristics of these items are nothing but what type of movie it is, right? What type of movie? Like first movie, if you see, the movie is of drama type, which we call as genre. Then this movie is directed by F.F. Coppola, who is the director of this particular movie. Then we have a running time. The running time of this movie is 175 minutes. And details about this movie, or you can also keep who is the actor, who is the actress, and a detail more details about this particular movie. Because if once suppose you want to learn a particular topic, you can simply type the topic in the YouTube. But you want the topic need to be explained by some YouTuber, right? Within 5 to 10 minutes. So you can go to the advanced search. You can restrict it to 10 minutes. So if any video which is below 10 minutes, that is only going to be listed, right? Because many times people don't have time. They are looking for a very small video or short movies, right? That's why running time is also very much important. Type of movie is also important. Suppose you like drama type movie, tomorrow a new movie is released that is related to drama, then definitely that drama movie is going to suggested to you in your different platforms like Netflix and other platforms, right? Similarly, if you go for the item number 5, you can see the genre or type of this movie is it is a romantic type, and it is directed by James Cameron. The running time of this movie is 195 minutes. And details about the movie, who is the actor, actress, plot, and everything you can there in the database. Okay, so these type of informations we are available in the database, right? So you have to decide that which information you want to keep or discard in order to build a particular model. Basically, we call this information as content-based information because content-based information focuses on the discrete characteristics of the items, right? Now, not only this is important, but also feedback plays a very important role. Like if I ask these users related to a particular movie, if they have watched that movie or they have listened that movie from others, then they can comment on that particular movie. Like I asked user E1 related to movie I2, user 1 rated that movie as 2 out of 5. Right? But when I asked user 3 related to the movie I4, U3 says that she has seen this particular movie. Right? If you consider these two cases, you can see here the feedback is in a particular scale, right? That is, you can say 1 to 5. But this particular one is not in a scale, but rather than it is a binary. Whether one person has seen a movie or that person has not seen a particular movie. So based upon the different type of feedback, we can categorize the feedback into 2 types. One is called as explicit feedback, another is called as implicit feedback. So let us discuss about what is explicit feedback, implicit feedback in detail. So explicit feedback means a system where we rely on user giving us explicit signal about their preference. Like in this case, we have seen user one is giving you an explicit signal. User 3 is also giving you an explicit signal. Right? Explicit signal may be the ratings. Explicit signal may be the thumbs up symbol or thumbs down symbol. That is binary. Like after reading a particular article or a troubleshoot page or a blog, at the end of the blog it is written that was this information useful, then there is a thumbs up button and there is a thumbs down button. If you are happy with that particular solution, you can click thumbs up. If you are not happy with that solution, then you have to click thumbs down. So all these cases you can see the user is providing you explicit signal, but always user is not going to give you an explicit signal. Like sometimes you are watching a particular uh, movie, you are getting an interesting ad, okay, and that ad is so much attractive. It is very much attractive. So you are moving from you are moving to that particular site. You have clicked that particular ad, so your movie is paused and you are redirected to that particular site. So that is nothing but it is a click. Or sometimes you are posting some questions in some social networking website, or you can say Quora.com. People are used to comment on your questions. Sometimes you also see some kind of videos. So these are not your intention, but unintentionally you did it, right? You have clicked it. Your main intention is to watch that particular movie, but you are redirected to another website. Okay, so by looking into, if you see the feedback, that is called as your implicit feedback. So you can say implicit feedback is based upon user clicks, queries, watches to infer the preference. But if there are lack of clicks or lack of query or lack of watches, then it is also leads to lack of preference. So you have to consider both type of feedback, whether it is an implicit feedback or explicit feedback. You have to consider both. Now, not only this content-based information or feedback is important, other informations are also there. Another information you can see here that is called as a demographic information. So demographic information means, there are some e-commerce sites. When you enter to that e-commerce site, they'll ask you whether you want to purchase a male-oriented product or you want to go for a female-oriented product. So that is related to the demographic information. The user is interested for a male or female. A male can purchase for female, a female can purchase for male. But you can categorize the sections based on the male and female. There are some products are there that is with respect to the age group. You can say the age groups are 0 to 10, let's say 11 to 20, 21 to 30, 31 to 40, or 40 to 51, 41 to 50, or 50 plus, 51 plus, right? So based on these, based upon their necessity, you can also categorize the different type of products. There are some also products are there which is based upon the profession of the user, whether the user is a teacher or the user is a student, user is a journalist, user is a medical professions. So based upon this also you can categorize different products, right? Suppose I am interested only in books, right? So while you can see also various e-commerce sites, they have categorized into various sections. If you are interested in book, you can go to the books and there you can search related to the books. Because while you are making a particular search, some keywords are matching with other sections also. In order to avoid that, we can go to that particular section and search for that particular product. At last, you can see social information is also very, very important. In social information, you should know how a user is connected to another user. Like here you can see user 2 is connected to user 4. So we can say user 2 or user 4, they are friend of each other. Suppose U2 is not connected to U3, then you can say they are not friend of each other. Even if two users are friend of each other, you can also give a trust value. Let's say the trust value is in the range of 0 to 1. If the value is close to 1, you can say that both friends are close to each other. If the value is near to 0, they are normally friends. So based upon that also you can make the predictions, right? Because if your close friend suggests something, right, you are definitely following that one. Your friend suggested that to watch a particular movie, and definitely in the weekend you are planning for that particular movie. Okay, so like whenever we have purchased a particular product also, we ask different people who are in our circle, and based upon their feedback we purchase that particular item. So social information is also very much important. And this is not a complete list. There are a lot of informations are also there, but you have to think about what information are required and what information you can skip, right? Now, if you see the database perspective, let us see in the database perspective, how it actually look like. You know, database case, we represent everything in the form of a table. The table is just like our Excel files. So if you go for item, if I want to keep the characteristics of a different item, like I have mentioned item ID, let the item ID is 101, and the type of that particular item, let's say it is drama type, there is nothing but a type of movie. Director, as I said, it is FF Coppola, right? And details about that particular movie. If you want to keep actor, actress, that you can keep. Suppose another movie is there, which is having the ID 102, which is a romantic type, and it is directed by, let's say, James Cameron, and detail about that particular movie. So whenever a new movie is coming into picture, so you have to assign a item ID, you have to categorize that movie into one of the type, and you have to mention the director or the name of the movie. Other things you have to mention in the form of a table. Now coming to feedback. In feedback case, we have seen different type of feedback like explicit feedback, implicit feedback. So a user generally gives a rating to a particular item. Like user U1, right, purchased item I1 and rated that item as 4 out of 5. So you can insert that into rating table. Suppose user E1 purchased another item, let's say I5, and rated 2 out of 5. That you can enter into the table. So whenever a transaction happens and the user rate that particular product, that you can maintain in a particular table. In the similar fashion, you can maintain another table that is called as consumption table. Like YouTube, you are watching a particular video, right? You are watching a particular video repeated, like one new song is released by your favorite singer. So you are listening that music several times. So when you go for this rating table has some limitation. Like it will say, suppose your user ID is 10 and that music ID is, let's say, I58, and you rated 5 out of 5. But here you have not explicitly shown how many times you listen that particular music, right? That the rating says that definitely you are interested in that particular song, and you like that particular song, you love that particular song, but how many times you have referred that particular song, you don't know. Similarly, you may also like another item song, that is I17, also you rated 5 out of 5. So how to know your favorite song? So it is very difficult to determine. But when you go for the consumption table, what we are maintaining number of times as well. So number of times says that suppose U10 has listened I58 for 38 times. Or you can say U10 listen I17 for 57 times, right? So you can say that obviously user prefer this particular music over this one, although both the music rated 5 out of 5, but it is if you see the number of times, we have seen that I-17 is less in maximum time in comparison to I-58. In this way, the rating table is different from the consumption table. Now, coming to the demographic informations, we have seen three different demographic information. One is called as gender, another is called as age, another is called as profession. So what I can do, I can write user ID U1, gender is 25, gender is let's say male, and age is let's say 25, and profession is let's say student, right? Similarly, user number 2, the gender is female, and age is let's say 38, and he is a teacher, right? So we have to insert when a new user enroll into a particular system. Like if you have created a new Flipkart account, so that details need to be added into this particular table, right? Similarly, coming to the social information, if you see social information, here we are maintaining the friendship between two different persons. Like I can say U1 and U2, their friendship is let's say 0.8. U1, U3, their friendship is 0.1. So you can say in comparison to U1, U3, U1, U2 are close friends, right? So such type of information also you can maintain in the friendship table. So in the database perspective, what we have discussed that the informations are stored in the form of various tables, right? Like you have seen here, there are several tables we have considered here to keep variety of information. Okay. So before going to the second part, if you have any question, you can ask. Anybody having any question? Okay. Now coming to the second part of the recommender system, we'll see different types of recommender system. As I said, first we'll see there are two types of recommender system. One is called as collaborative filtering, based recommendation system. Another is called as content based recommendation system, right? Broadly, we can divide them into collaborative filtering system or content based system. Later point of time, we will see another further categorization of this collaborative filtering and content based, right? Which I will tell you. We'll discuss. They are called as memory based system and model based system. Here also in content based also you will find they are memory based system and model based system. But first we will focus on this one. Once you are comfortable in these two, then we will focus on these four types. So coming to collaborative filtering system, collaborative filtering approach builds a model from a user's past behavior. So for a particular user, let's say the user is U1. U1 has purchased 5 different items. Okay, let's say these items are I1, I5, I15, I38, and I100. So based upon these items, because user has purchased this item, so you have to suggest some new items to this particular user. For this, you have to build a particular model. And this model takes input as whatever the items you have purchased. Based upon that, it is suggesting some new items, right? So this is the first part. Coming to the content-based recommendation system. So content-based approach utilizes a series of discrete characteristics of an item. We'll see the characteristics of item. Like you can see I1, I5. Let's say I1 belongs to home and decoration. I5 also belongs to home and decoration. Price wise, if you see, the price of I1 is less than 1000. Price of I5 is also less than 1000. So we are looking into various characteristics of an item. Why we look into these characteristics? Because we are going to suggest some additional item based upon the discrete characteristics of the existing item. You are going to suggest, you have to recommend some additional item, and these additional items are having similar properties as those items are taken by the user earlier or purchased by that particular user. First, you need to know discrete characteristics of the item. Then you have to suggest similar items which matching the properties with the earlier items, right? In this way, the collaborative filtering approach is different from the content-based recommendation system. Let us take an example to understand how a collaborative filtering system is different than content-based system. Like here, I have considered two different users. You can say this is your user U1, this is user U2. Okay, suppose U1 referred a book I1, U2 also referred a book I2. Okay, so the book I1 and I2, they are similar, or you can say both users read I1 as well as I2. So as both have used the I1 and I2, both user is interested in these two books, then you can say these two users are similar to each other. Like you are interested in this FDP, your friend is also interested in this FDP, then you can say the choice of both of your friend is same. Okay, maybe you are belong to the same department, maybe you are working in the same research area, or maybe you are interested to know the same research area, so they are related to each other. So whenever a new book is indexed, right, let's say the new book is I3, or whenever a new book is coming to the market, right, if that book is read by this user U2, automatically that is going to recommend it to U1. Okay, U2 has no idea about I3, only U2 read that book I3. So that is the reason why I3 is recommended to user E1. So what you are actually doing here, you have generated a model based upon their past behavior. This is the past behavior of the user. Based upon their past behavior, you have developed a particular model, and the model suggests a particular item if that item read by one of them. Like here you can see I3 is read by the user U2. That is the reason why I3 is recommended to user E1. So such systems are called as collaborative filtering based recommendation system. Here primarily we focuses on the user, but we are not focusing on the item. We give more focuses on the user part, not in the item part. Now coming to the content-based system, let us consider this is user U1, this is item I1. Right, user U1, this is item I1. User U1 read the book I1. Later point of time, another book is indexed in, let's say, Flipkart or Google, that is I2. But if you see the content of I1 and I2, they are more or less same, or there is some connection between I1 and I2. Like here we say that the article I1 is same as article I2. They are similar article. So as these items are similar, so item 2 is suggested to U1. Right? In the previous case, what you have seen, you have considered similar users. But what we did here, we have looked into discrete characteristics of item I1, discrete characteristics of item. by looking into the discrete characteristics, we have concluded that item I1, item 2, they are similar. So we can recommend, right, item I2 to user E1 because I2 has similar properties as I1. So that system is called as the content-based recommendation system. So these two are the basic categorization of the recommendation system. Now let us discuss in the database perspective how it will look like. Coming to collaborative filtering system, collaborative filtering systems considers the ratings and consumption. So these ratings and consumptions are nothing but the relationship between the user and item. Like user 1 purchased a particular item I1, suggested that is 5 out of 5. Or user 1 listened a music I5 for 50 times. So these are nothing but the rating metrics and consumption metrics. So when you go for collaborative filtering system, the rating metrics and consumption metrics is given to you. Rating metrics and consumption metrics is given to you, right? Because you should know what is the input, right? What are the informations that are available, right? So this rating metrics and consumption metrics is given to you. So let us see how the rating metrics look like. So as I said, the rating matrix is same as, you can say it is a Microsoft Excel file. Like here, you can see there are 11 different users and 15 different items. So 11 users are numbered like this, U1, U2 up to U11, right? And 15 different items are given as I1, I2 up to I15, right? I1, I2, I15. Then you can represent it in the form of a matrix kind of thing or in a table in order to capture the rating of user E1 against a particular item. Like what this 5 indicates? This 5 indicates that user E1 rated I1 5 out of 5. What this 2 indicate? This indicates that user 1 rated I7 2 out of 5. Similarly, this yellow marked box, if you look into this particular location, pointing to user U6, also pointing to item I7. So we can say the user 6 has rated item I7 4 out of 5. But if there is a blank one, or it is represented by dot here, or a blank cell, that represents that user U2 has not rated the item I10. Like here you can see this blank space belongs to U2 and this is belongs to I10. That is the reason why we are saying user U2 has not rated the item I10. And if you look into the whole matrix, you can find the ratings are in between 1 to 5. So can anybody tell whether it is an explicit feedback or it is an implicit feedback? Is it an explicit feedback or it is an implicit feedback? Any comment? The scale is given as 1 to 5. So you have to say whether it is an explicit feedback or it is an implicit feedback. So whether user is giving an implicit signal or it is an implicit signal. Any answer? Okay, so it is an explicit signal, right? I told you ratings are generally explicit signal, or thumbs up, thumbs down button is also explicit signal. But whenever you are making some kind of query, some watches or some clicks, they are called as your implicit signal. Now, not only the rating matrix look like this one, you can see different variants of the rating matrix. Like if you look into this one, this is another variant of your rating matrix, right? Like here you can see what this +1 indicates. This +1 indicate user 1 rated I1 is +1. So only the value is +1 -1. So you can say U1 liked item I1. Okay. So see here, there is a -1 here. What it indicates? It indicates that the corresponding user, that is U2, the corresponding item, that is I7. So you can say U2 does not like the item I7, right? So this +1, what it indicates? It is corresponding to user 6 and I6. So we can say user 6 like the item I6. Okay. So if you see this particular rating matrix, in this rating matrix, the values are in the range of +1 to -1. Okay. And if there is an empty cell, like here you can see there is an empty cell corresponding to user 2 and item I10. So you can say user 2 has rated the item I10. So previous case, you can see there is a scale 1 to 5. So there is a rating in the scale of 1 to 5. In this case, we have -1 and +1. So one, you can say this is thumbs down button and this is thumbs up button. Right? In this way, user can express about a particular item, whether the user like that item or user dislike that item. Now, see another variants of the rating matrix. I told you, you will find several variants of the rating matrix, right? So if you see this particular variant, can anybody tell me what is the lowest value and what is the highest value here? Whatever value is seen in this particular slide, what is the highest value and what is the lowest value? Lowest value is 0, right? So here you can see the lowest value is 0. What is the highest value? Any answer? Highest value, is it 55? You can see here the value is 0 to 55, right? This is the highest value, I think, if I am correct. Yes. So what if this 55 indicates? It is corresponding to user E1, corresponding to item I3. So we can say that user 1 has listened to item I3, it is a music I3, for 55 times. Okay, but if you see this one, this 15 indicates the corresponding user is U6, the corresponding item is I7. So we can say user 6 has listened to item I7 for 15 times, right? And this 0 value indicates user 2 has not listened the item I10, because all the musics may not be listened by a particular user. You may have listened only a subset of the music, not the whole music, right? So not necessarily the rating matrix is in the range of let's say 0 to 1 to 5 or -1 +1. It may be in any range. On the other hand, you can say this is called as your consumption matrix. And consumption matrix, I told you, it is a type of rating matrix only. But there we are specifying the number of times rather than the rating value. Right? Now, if you see, if you go for content-based recommendation system, this is your content-based recommendation system. What you have seen the difference in the previous one, collaborative filtering system, you have seen that we are finding similarity between different users. But here we are focusing on similarity between different items, right? So we need items characteristics. Item characteristics means if you take the example which we discussed, in that case item ID is 101, genre is it is a drama type movie, and it is directed by Coppola, right? Okay, FF Coppola. So that you can say we are keeping that type of information, right? So in content-based information, you are given with items characteristics or items profile we can say, and also you are given with the user's profile. Like here you can see user ID, genre, right? Means you can say user 1 is interested in drama type movie. U2 is interested in a romantic type movie. U3 is interested in horror movie. User 4 is interested in, let's say, crime type movie. Right? Like that, you can make different categorization. Right? Not only this genre is available for item, but also genre is available for user. So if you can compare these two, you can easily say that what are the items available in that particular type. And if a user is interested in that particular type, then you can suggest that particular item to the user. Okay. Now coming to an example, so that you will know that whatever we have discussed in now, how actually it works. So for this, we need to consider the e-commerce website. And you know, e-commerce website like Flipkart and Amazon, they are selling thousands of smartphones. Okay, the number of smartphones are very, very high. But for taking a very small example, here we consider only 5 different smartphones. Okay, and each and every smartphone has a number of features, but we consider here only 2 different features. One feature is called as the battery, another feature is called as display. So what is this feature? Feature indicate that you are going to give some numeric value to battery or display, so that you can also see that these features in a particular user, not only item is provided that, but user is also given with these 2 features. So we compare the features value given by the user with the feature value that is given for item. Now I'm showing you the first matrix, that is called as item feature matrix. Okay, so in item feature matrix, what happened? You have we have considered 5 items, 5 smartphones. So they are smartphone 1, smartphone 2, smartphone 3, smartphone 5, 4, and smartphone 5. So if you consider 2 different features, let's say for battery case, smartphone 1 is 0.90 value, and display case the value is 0.10. So if you sum these two values 0.90 plus 0.10, you will get the value as 1. It means also that battery is better in the case of smartphone S1 in comparison to the display. Now, similarly, if you go for smartphone S2, you can see this smartphone is providing good battery, but it is not providing a decent display. Okay? That's why battery case it is 1.0 and so display case is 0. Similarly, coming to smartphone S3 case it is 0.99 battery and 0.01 display. So more or less all these smartphones are focuses on the battery, not on the display. But coming to the last 2 smartphones, S4 and S5, you will see the second feature, which is display, is better in comparison to the battery, right? So you can say display value of smartphone is 1, that indicates that this smartphone is good in terms of battery display, but not in terms of battery. Similarly, if you go for smartphone S5, you can see 0.9 it is display and 0.1 battery. So obviously, display is better than the you can say battery, right? So these type of features you can find in an item feature matrix. Now coming to the second matrix, that is called as a user feature matrix. So like different items, I have considered different features. And these features are also given their difference with respect to these 2 parameters or these 2 features. Like in this case, you can see I have considered 4 different users. They are Aman, Bob, and Chandan and David. And the features are, yes, one is battery, another is display. So Aman has given a statement that he prefers battery over display, is an ideal smartphone feature. So he has given 0.9 the battery and 0.1 the display. But when you come to the Bob, the second user, so he likes a long-lasting battery. So he prefers 0. He has given the parameter value is 0.80 and 0.20 for battery and display respectively. Now coming to Chandan. So for Chandan, display should be decent and battery should be normal. So you can say 0.10 the battery and 0.9 for display. Means first two users more or less are familiar with the battery. They are interested in a long-lasting battery rather than the display. And the next two users, they are interested in display or in the battery. Like David case, you can see 0.99 is for display and 0.01, that is negligible for David. So for David also, like Chandan, you can say display is extremely important, but battery is not important. So all these informations are available in that matrix, which we call as user feature matrix. So previous slide we have discussed item feature matrix, but here we focus on user feature matrix. Now you see there are the third type of matrix, which is called a rating matrix. Like here we consider 4 different users, we consider 5 different smartphones, and we have seen the different ratings given by the user. Okay, so we do not know the feature of the items here. We also do not know what is the feature of the user, but we have user's behavior, that how user rated the existing items. So in the case of collaborative filtering, you are the most important part which is given to you, that is called as your rating matrix. So looking into this rating matrix, you can say user 1 rated smartphone S1 is 5 out of 5, smartphone S2 is 5 out of 5, but user E1 has not purchased smartphone 3, smartphone 4, smartphone 5. But when you go for Bob, Bob rated 4.5 for smartphone S1, 4.0 for smartphone S3. The rest of the smartphones are not purchased by Bob. Similarly, U3 case, user 3 case, you can see user 3 purchased 4 smartphones, and he has underrated or said that there is a smartphone S2, smartphone S3 is not very good, but smartphone 4 and smartphone is good, right? Similarly, if you go for user number 4, you can say smartphone 4 and smartphone 5. Okay, the 4 and the 5 it is having a good rating, right? Although it is not 5, but they are close to 5. So the user more or less like that particular item, smartphone 4 and smartphone 5. Now, in this table, you can see you are even with only the ratings. As in the collaborative filtering, I told you, you are even with the ratings. In addition to rating, you are also given with the user feature matrix. Okay? You are also given with user feature matrix, but you are not given with item feature matrix. So if I ask you, what is the feature vector for smartphone S1 or S2, S3, that is determined, right? Because it is not easily readily given to you. So what you have to do, you have to assume the feature vectors. Like for this case, you can see we have assumed that the feature vector for smartphone S1 is X1 and X2, right? So we have assumed it because by taking the rating matrix and user feature matrix, we have to find what is the rating for item feature matrix. So we know that the user E1 smartphone S1, the rating is 5. So here you can consider U1 S1 transpose is equal to 5. And you can represent the smartphone because we are interested in finding smartphone H1 feature. So you can see this value which you can say U2 S1 transpose, which is 4.5. Okay, U1 S1 transpose is 5, U2 S1 transpose is 4.5, right? But if you look into this one, you can see, you know, this U1 part, you know this U2, because this is your rating part. This is the feature for item, and these U1 and U2 are the feature for your user. So what you can do here, that if you know the U1, U2 value, I'll give you that value here in the next slide. So you can easily find what is the value for S1 transpose and S2 transpose. Now, this is your user feature matrix. So in the previous slide, it is, you have seen U1 S1 transpose is equal to 5. And also you have seen U2 S1 transpose is 4.5. So if you go for user U1, the feature vector for user U1 is 0.9 and 0.1. If I put it into this equation, that is 0.9 and 0.1 for U1, and S1 transpose I don't know. So I have given some variable for it, that is x1 and x2, transpose is equal to 5. So if you solve this equation, right, you will get 0.9 x1 plus 0.1 x2, which is equal to 5. Similarly, if you take the second one, that is U2 S1 transpose is 4.5. U2, you know, this feature vector is 0.80, 0.0. So 0.80, 0.20, S1 is your again x1, x2 transpose is equal to 4.5. So if you solve this equation, you will get 0.80 x1 plus 0.20 x2, which is equal to 4.5. So this is one equation, this is another equation. So there are two unknown. One unknown is x1, another unknown is x2. If you solve these two equations, you will get the values of x1 and x2. For example, I'll take the equation 1 as it is by taking 0.9 x1 plus 0.1 x2 is equal to 5. But I'll multiply the equation 2 with the 2. So 0.80 becomes 0. Okay. Sorry. Yes, you can see here. Yes, you can multiply the first equation, not the second equation. Just a minute. So you can multiply the first equation by 2. So it is 1.8 x1 plus 0.2 x2 is equal to 10. Because I want to cancel this x2 part, that's why I have multiplied equation 1 with 2, not equation 2 with the 2, right? So if I take the equation 2 as it is, then it is 0.8 x1 plus 0.2 x2 is equal to 4.5. So if you subtract it, right? So you know 1.8 minus 0.8 is x1 only. These two will cancel out, is equal to your 5.5. So now you know the x1 value is 5.5. If you put this x1 value in one of the equation, then you will get the value of x2. For example, if I put it here 0.9 into 5.5 plus 0.1 x2 is equal to 5. So if you multiply 0.9 into 5.5, how much you will get? Can anybody calculate and tell? 0.9 into 5.5. You will get the value as, I think, 4. Just a minute. Yeah, you will get the value as 4.95 plus 0.x2 is equal to 0.1 into x2 is equal to 5. So x2, I'm writing here, x2 is nothing but 5 minus 4.95 divided by 0.1. So 5 minus 4.95, you know it is 0.05 divided by 0.1. If you do this one, how much you will get divided by 0.1, you will get the value as 0.5. Now you know the value of x1 and x2. So by taking the rating matrix and the user feature matrix, you would be able to find the item feature matrix. So now similarly, you have to find the feature for user 2 as well. Like user 2 case, if I go to previous slide, I can say you here, like if I go for smartphone S2 feature, so you can say U1 S2 transpose is equal to 5.0, and this value is like this, right? If I take this value, I can say U3 S2 transpose is 0.5. So you know U1 value, if you take U1 value is 0.90, 0.90, 0.10. S2, let us assume it is x1, x2 again, is equal to 5.0. Here, if I take U3 is, you can see here, U3 value is 0.10 and 0.90. I am taking this one 0.10, 0.90. S2 is x1, x2 is equal to 0.5. So if you solve this one, you will get 0.9 x1 plus 0.1 x2. So here transpose is there, is equal to 5. Here it is 0.1 x1 plus 0.9 x2, you will get 0.5. So if you multiply, this is, you can consider as equation 1, and this you can consider as equation 2. So if I multiply equation 2 by 9, right? So if I take equation 1 as it is, so it is 0.9 x1 plus 0.1 x2, which is equal to 5. And equation 2, if you multiply with 9, then you can cancel one thing, right? So we can say 0.1 multiplied by 9, you know this is 0.9 x1 plus 0.9 into 0.9, you will get 8.1 x2 is equal to 0.5 into 9, you will get 4.5. So if I subtract it, this is cancelled, this is minus if you put, and it is 0.1 minus 8.1, you will get 8. So it is nothing but 8x2, right, which is equal to minus 8x2 is equal to, if you do here, this is 5 minus 4.5, you will get 0.5, right? Okay, so what you can do here next, okay, if you find the x2 value, you will get x2 value as, I think you will get x2 value as close to 0 only, right? You'll get the x2 value is 0 because I think it is going negative. That's why the value you can consider here is negative 0, right? Value is x2 is 0. So if you put x2 value here, then 5 divided by 0.9, 5 divided by 0.9, you will get the value which is close to 5.5. Right? Rating cannot be negative. That's why we consider this as 0, because 0.1 minus 8.1, you will get minus 8x2, and this is 0.5. So x2 is 0.5 divided by 8. It is a negative value, so we consider that as 0. In the similar fashion, if you find the S3 feature, S4 feature, S5 feature, you will get the corresponding x1 value and you will get the corresponding x2 value. Like here you can see, yes, these are the feature value for S2, S3, S4 and S5. So now you know all the feature vector, right? Starting from S1, S2, S3 up to S5. So now if you go for the recommendations, so the recommendation will be mapping of the user feature vector, which is this one. This is called as a user feature vector. And the item feature vector. These are the item feature vector. For example, for Aman, actually, if you want to, based on his preference and behavior, if you suggest something, so you can do that is maximum of U1. U1 is actually Aman. So U1 with S1 transpose, U1 with S2 transpose, U1 with S3 transpose, U1 with S4 transpose, and U1 with S5 transpose. And you know the U1 users values in this particular table, you know the smartphone feature. So if you multiply these two, like here U1 feature, you can take 0.9, 0.1, 0.9 and 0.1. If I multiply with this smartphone feature which we found here, x1 is 5.5 and x2 we found as 0.5. So if I take this one, that is 5.5 and 0.5, if you multiply them, okay, then you will get the value as 5. Similarly, you take U1 and multiply with S2 transpose, you multiply U1 with S3 transpose, you multiply U1 with S4 transpose, you multiply U1 with S5 transpose, and you will get the values are 5, 4.99, 4.95, 1 and 2.9 respectively. So if you look into this one, the highest value is for smartphone S1, right? Second highest value for smartphone S2, third highest value for smartphone S3, fourth is nothing but fifth one is the coming in the fourth, and the fourth one is coming in the fifth. So in this order, you are going to suggest different smartphones for the user number you want. So here another important concept comes into picture, which is called as top-end recommendation system. If you go for top-end recommendation system, we are suggesting you can say n different items, right? N different items to a particular user. For example, I want to consider only the top two. In this case, then I am going to suggest S1, S2 to the user U1, which is Aman, right? But if you go for top 3 recommendation system, in addition to S1, S2, you are going to suggest S3 to that particular user. Okay, so in this way, actually, we make recommendation in the collaborative filtering system. Now, on contrary, the second type of recommendation system which we have, that is called as content-based recommendation system. If you go to the content-based recommendation system, it recommends item based upon the similarity comparison between the contents of the item and the user profile. Basically, it is taking this item feature matrix. This one is called as your item feature matrix. This one is called as your user feature matrix. So there is no rating matrix given here in the content-based recommendation system. So you can consider the feature directly, and suppose you want to suggest something to Aman. So what you will do? You will take U1 S1 transpose, U1 S2 transpose, U1 S3 transpose, U1 S4 transpose, U1 S5 transpose. So if you do so, for U1, you will get 0.9, 0.1 multiplied by 0.9 and 0.1. For U1 S1 transpose, let's say 0.9, 0.1 to 1 and 0. Here also 0.9, 0.1 with 0.99 and 0.01 transpose. Here also 0.9, 0.1 with 0 and 1 transpose, 0.9, 0.1 with 0.1, 0.9 transpose. So if you solve these values, you can see these values are already solved. If you solve these values, you are going to get the values are 0.82 for the first one, 0.9 for the second one, 0.89 for the third one, 0.1 for the fourth one, and 0.18 for the fifth one. So if you see for the smartphone S1, S2, S3, S4, S5, if you order in this manner, the highest one you are getting for the smartphone S2. So first for the Aman or user U1, if you want to suggest some smartphone, then first you suggest smartphone S2. Then the next highest value is smartphone S3. So you suggest S3, then you suggest a smartphone S1, then you suggest smartphone S5, then you suggest smartphone S4. So in this order, you have to make suggestions to Aman. The only difference you can find in the collaborative filtering and content-based system is that the type of matrix that is given to you as a input, you can say, or as a available of that particular data. So in the first case, we have the rating matrix and user feature matrix. In the second case, we have user feature matrix and item feature matrix, through which we can make a recommendation. Although these two filtering systems are having their own advantages and disadvantages, we'll see one of the very popular problem which is there in the collaborative filtering system. Now, if you go for collaborative filtering system, here you can see, so in the previous cases, you know that we consider 11 different users and we consider 15 different items. We consider 11 different users, we consider 15 different items. Suppose a new user is coming to your system. Assume that Flipkart has 11 users and 15 items. For taking an example, if 12th user is enrolling in the system, then if 12th user is enrolling, then which item you are going to suggest to that particular user? Because user U12 do not have the past behavior, or this particular user, you don't have any purchase history. So it is very difficult for this user to suggest some item. So we call that problem as cold start problem. Okay, this is a very popular problem in the case of collaborative filtering system, where we consider this particular problem with respect to two perspectives. One is with respect to the new user, another is with respect to the new item. Right? So what actually we are doing here? We consider new user and new item by adding a new user to the system, by adding a new item into the system. But unfortunately, we are not able to assign or not able to suggest some items to this particular user. So obviously, it suffers from new user cold start problem. So you can suggest that the items that is purchased by most of the user, or the maximum number of users, that item you can suggest to you to avoid the cold start problem. So that may be one of the you can say method to suggest a item to this user. For example, if you see in this context, if you look into, I think item number 7 is purchased by 1, 2, 3, 4, 5, 6 different users. So you can suggest item number I7 to user U12. As the initial case, you can say also. So this particular problem is called as the cold start problem with respect to the new user. Now, if you go for new item, right? If you go for new item, so like we have here 15 different item. We want to add an additional item, that is I16, and like the previous case, we have new user. This case we have new item, but again, this new item is not recommended to any user, because for this item you do not have any user history. Like if I ask you for I13, then you can say U13, you can say these are the 4 users that that is user number 5, user number 7, U8, and U9. These are the 4 different users have purchased the item I13. But when you go for I16, you do not have any purchase history. That is the reason why you can say that is the reason you can say why the I16 is not suggested to any particular user. So this is another form of cold start problem with respect to the new different item. Now you may have something in your mind, okay? You have something in your mind that if you go for content-based system in case of collaborative in place of the collaborative filtering system, does this particular problem, which is a cold start problem with respect to the user, with respect to the item, persist or not? So let us see. Like if you go for the database, right? This database, if you can see that this is your user profile and this is your item profile. We have set of users, we have set of items and their profiles. Like we have, let's say, a set of users. We know what type of movie they like user U1 like terror type movie, user 2 is like romantic type of movie, and other users also like similar type of movies. So whenever a new user is enrolling into your system, you can ask the user what kind of movie you like. Suppose the user says that, okay, I like crime type movie. Then you can go to the item matrix, and in the item matrix, you can search for the crime type movie. Like one of the crime type movie is Godfather, and you can select the crime type movie which are rated close to 5. Such movies you can recommend to this particular user. Only you need to collect one information that whether information that whether this new user, right, likes the crime type movie or terror type movie or romantic type movie or whatever the classification or whatever the different types of movie you have. With that information, what you can do, you can search in the item feature matrix and suggest a set of movies or the highest rated movies to that particular user. So the cold start with problem with respect to the new item is not a problem in the case of content-based system. Now coming to the last part of this lecture, I'll discuss rest of the part later. So we'll solve another question here, part of the question, which is called as how to evaluate a recommender system. Like I told you, there are several parameters we need to consider in order to evaluate the performance of the recommendation system. So the first parameter you can consider, that is for any machine learning model, you know, we are calculating accuracy, right? So accuracy is a prime factor for every type of model. Here also it deals with model, so we will deal with the accuracy. So if you look into accuracy, accuracy asks you a question that do I like what the recommendation system recommends me, right? So if a recommendation system, like here you can see the recommendation system has suggested I1 and I3 to user number 1. So if this user likes actually I1 and I3, let's say U1 likes both I1 and I3, then you can say the accuracy is 100%. But if you see that a user U1 likes I1, does not like I3, then you can say accuracy is 50%. Or on the reverse side, you can say user U1 does not like I1 but like I3, then it is also 50%. But if your user does not like both of the item, then you can say accuracy is 0%. That's why we are very interested to know that do I like what the recommendation system actually recommends me. The second parameter or evaluation matrix that we have considered, that is called as a diversity. So diversity says that diversity focuses on here that says that does the recommendation system suggest me a different kind of item. Like if you see the recommendation system, we are not looking into only one type of item. A user may be interested in several items that are available in different category. So the question arises whether the recommendation system offer a variety of items or it is only focusing on one category of item by skipping the rest of the category of the item. So that actually diversity defines in the recommendation system. Coming to the trust, right? The third parameter, which says that has the recommendation system the ability to convince me about their recommendation. Sometimes recommendation system also provides some additional information. Nowadays also it provides that if you purchase this item by today midnight, it will be delivered to you by day after tomorrow. Or sometimes it says that this particular item is purchased by uh, 10,000 users and the rating of this particular item is 4.5. So that it really focuses on the trust of the recommendation system. There are various ways recommendation system can also suggest you that item by providing some kind of offers or some kind of coupon codes or some kind of attractiveness so that you are going to buy that particular product. So trust is based upon the reliability and explaining a particular recommendation, why that recommendation is given or that is generated by the system. The last one is related to the serendipity, and serendipity actually focuses on the nobility of the system. What is new thing in the system? Nowadays, now all the shop owners or the e-commerce sites, they are wishing you in your anniversary date, or you can say in your birth date, or you can they are saying that there is an attractive offer for you because this is your birthday month, or they are also suggesting you some particular category, right? If you are going to purchase anything in the cloth category, you will get this much discount. So this is nothing but some kind of nobility with respect to different users, because all the users are not falling in the same date, right? Their date of birth is not falling in a particular date or a month, right? So a special kind of attentions the recommendation systems are doing so that the user may be interested to purchase this item from that particular e-commerce site. Or nowadays they are dropping the SMS and various medium to attract the customer towards their system. Okay, we'll stop here. In the next class, I'll continue with the third questions, which we have addressed in the second, that how to implement a recommendation system. So if you have any question, you can ask.